But can I confirm whether you can hear me? Anyone can confirm?
Can hear.
Yes. Okay. Also, you have to turn on your videos. Right. Quick. Right. Quickly. Right. Fine. Hi. There. අපි වැඩේ පටන් ගමු. First of all, good morning to all of you. අද ටිකක් ලොකු වැඩක් තියෙන්නේ. ටිකක් නෙමෙයි සෑහෙන ලොකු වැඩක්. මොකද මම ටියුට් එක දාලා තියෙන group එකට මම හිතන්නේ වැඩි දෙනෙක් ටියුට් එක print outs අරගෙන ඇති. මොකද ටියුට් එකේම ලියන්න දේවල් තියෙනවා. කාට හරි print out එකක් ගන්න time එකක් නැති වුණා නම් ටියුට් එකේ page number එක දාලා එතෙන්ට අදාළ දේ ලියා ගන්න දැනට පස්සේ ටියුට් එක අනිවාර්යෙන් 27 A level කෙනෙක් නම් අනිවාර්යෙන් ටියුට් එක complete කරන්න. මොකද මේක එච්චරටම වැදගත්. right? එතකොට අද නිවාඩු දවසක්. ඒවර නිවාඩු දවසක අපි අද මේ වගේ වැඩකට ඇවිල්ලා ඉන්නවා. ඒකම එක පැත්තකින් ගත්තොත් ඩෙඩිකේෂන් එකක්. ඒක නිසා ඒකෙන් උපරිම රිසල්ට් එකක් ගන්න ඕනේ. ඇත්තටම මේකෙන් උපරිම රිසල්ට් එකක් ගන්න ඕන දවසක් අද. එතකොට අද හෙට අනිද්දා ওই දවස් තුන ඇතුළත මේ පාඩමේ මේන්ම ලොකුම ඒරියාස් ටික කවර් වෙනවා. questions එක්ක discussions ඒ හැමදේම එක්ක. එතකොට කිසිම ප්‍රශ්නයක් නැතුව හැමදේම කරගන්න පුළුවන් මට්ටමකට කොහොම හරි ගන්නවා. මේකේ කරන්න ඕන දේවල් මෙහෙමයි. හරියට කියලා දෙද්දි අහගන්න ඕන. මොකක් හරි ප්‍රශ්නයක් තියෙනවා, මොකක් හරි අවුලක් තියෙනවා, මොකක් වුණත් කවන්නේ මෝඩ ප්‍රශ්නයක් වුණත් කවන්නේ දා. හරිද? මාත් මෝඩ ප්‍රශ්න ඕන තරම් ඉගෙන ගන්න කාලේ අහලා තියෙනවා. ඒක නිසා ඒක ගැටලුවක් නෑ. මොන ප්‍රශ්නයක් හරි කවන්නේ මොකක් හරි අවුලක් තියෙනවා නම් ටක් ගාලා chat එකට දාන්න. එහෙම නැත්නම් කතා කරලා අහන්න. අවුලක් නෑ. හරිනේ? ඕනම් ප්‍රශ්න ඕනම එකකට ආන්සර් දෙනවා. අනිත් එක ආයෙ එක්ස්ප්ලেইন කරන්න කියනවා නම් ආයෙ එක්ස්ප්ලেইන් උත් කරනවා. එතකොට අපි අද කරන plan එක first of all I will start with Newton. I will start with Newton. Right? එතකොට නිව්ටන් කිව්වහම මේක ඇත්තටම නිකන් F equal ma දැමිල්ලක් නෙවෙයි මෙතන තියෙන්නේ. F equal ma නිව්ටන් කියන්නේ O level physics. හරිනේ? ඔය විදිහට කරන්න ගිහිල්ලානේ ඇනුනේ. ඒක නිසා මෙතන ඊට වැඩිය ලොකු ස්ටෝරියක් තියෙනවා, ලොකු ගණන් ගොඩක් තියෙනවා. එතකොට ටියුට් එකත් එක්ක ගිහිල්ලා ගණන් හදන ගමන් මේ වැඩේ සම්පූර්ණ ආයේ නිව්ටන් සුපිරියටම ඉවරක් කළා දා. ඊට පස්සේ second linear momentum. ඔය conservation කතා අනම්මන ඔය කතා ඔක්කොම කරනවා. third work energy power. Right? third work energy power. Right. එතකොට අද අපි බලමු ටයිම් එක හම්බෙනවා නම් ටයිම් එක හම්බෙනවා නම් අනිවාර්යයෙන්ම අපිට පුළුවන් ඊළඟ සෙක්ෂන් එක මොමන්ට් center of gravity equilibrium වගේ පාර්ට්ස් වලට යන්න. මගේ ටාගට් එක ඒක නම් හෙට කරනවා කියන එක අපි පුළුවන් තරම් උපරිම questions වලට යන්න ඕනේ අනිවාර්යයෙන්. මොකද questions වලින් තමයි මේවා හදන්න පුළුවන්. කොච්චර theory දැනගත්තත් බැරි නම් මේ වැඩේ හරියන්නේ නැහැ. right. ඕකේ. එහෙනම් අපි අද වැඩේ පටන් ගමු. පටන් ගද්දිම කියන්නේ එක question එකක්වත් අතෑරින්න නැතුව හදන්න. හරිද? මම theory part එක discuss කරලා ඊට පස්සේ question එක දෙන්න. question එක දෙන්නේ question එක හදන්න ඕන නිසා. question එක හැදුවේ නැත්නම් කවදාවත් හරියන්නේ නැහැ. හරිද? ඒ කියන්නේ theory part එක කරලා ඊට පස්සේ වරදින්න හරි හරියන්න හරි හදන්න ඕන. ඉතින් හරිය හදන හැම එකම හරියනවා නම් මේක අවුලක් තියෙනවනේ. හදන හරියකම හැම එකම හරියනවා නම් මේ සබ්ජෙක්ට් එකට මෙහෙම වෙලා හරියන්නේ නැහැ. මේ සබ්ජෙක්ට් එකෙන් 3% විතර ඒ පාස් වලට යනවා. මේ 5% විතරයි. එතකොට ඒක නිසා අනිවාර්යෙන්ම වරදින්න හරි හදන්න ඕන. ඒකෙන් ලොකු ඉෆෙක්ට් එකක් තියෙනවා. අත්දැකීමෙන් කියන්නේ. right. හරි. කට්ටියම ටියුට්ස් ගන්න. ටියුට් එක ගන්න ෆොටෝකොපි කරගත්තා නම් වැඩේ ගොඩක් හොඳයි. එහෙම නැති වුණත් මාර කියපු විදිහට වැඩේ කරගෙන යන්න. හරි. මම කියන කැහෙන නැතිනේ. මොකද ප්‍රශ්නයක් තියෙනවා නම් chat එකට දාන්න. right. okay. මෙහෙමයි කතාව. Newton's laws of motion. කතාව පටන් ගත්ත ගමන් මතක් වෙන්නේ F equal ma. හරිද? ඒ මගුලක් නෙවෙයි. Newton's laws of motion කියපුවම laws තුනක් තියෙනවා. එතකොට මේ laws තුනෙන් දෙවෙනි law එක තමයි F equal ma කියලා කියන්නේ. හරිද? ඕක තමයි අපිට ගොඩක් relate වෙන law එක. හැබැයි ඔය law එකෙන් ගණන් හදන්න නම් මේ law එකෙන් calculations කරන්න නම් මේක හරියට දැනගෙන ඉන්නත් ඕන. මේක හරියට දැනගෙන ඉන්නත් ඕන. So you have to know all three laws in order to solve complex calculations. right. අපි වැඩේ පටන් ගමු. මොකක් හරි explain කරන්න ඕන තැනක් තියෙනවා අනිවාර්යෙන් ආයෙත් කියමු. හරි. Newton's laws of motion වල Newton's first law. Newton's first law of motion. හරි. මේක කියන්නේ මෙන්න මෙහෙම කතාවක්නේ. වැඩේ අමාරු නෑ. හරිද? law එකේ කියන්නේ මොකක් හරි object එකක් තියෙනවා. මම මෙහෙම block එකක් ගන්නවා. හරි. එතකොට මේ law එකේ කියනවා until an unbalanced force acting on an object. හරිනේ මතකයිද? ඇයි unbalanced කියන්නේ? balance වෙලා හරියන්නේ නැහැ. මම law එක පළවෙනියෙන් කියනවා. until unbalanced force acting on an object. first point එක unbalanced force. Until an unbalanced force acting on an object at rest මොකද්ද? remains stationary. object at rest remains stationary. And objects at uniform velocities moving in their same velocities. ඕකනේ කතාව. හරි. ඕක අපි කියලා තියෙනවා ටියුට් එකේ. An object will remain at rest or move with constant velocity in a straight line unless acted upon by a external resultant force. හරි. එතකොට මොකද්ද වෙන්නේ? constant velocities වලින් යන අය constant velocity වලින් යනවා. හරිනේ. rest එකේ ඉන්න අය rest එකේම තියෙනවා. constant velocities වලින් යන අය constant velocities වලින් යනවා. හරි. දැන් ඕක ඕන බූරුවෙට තේරෙනවා. ඕක නෙමෙයි දැන් ප්‍රශ්නේ. දැන් මං ඇයි කියන්නේ මෙතන යුනිෆෝම් වෙලොසිටිස් කතාව. මේක දැන් මං හිතන්නේ ගොඩක් අයගේ අයිඩියා එකක් ඇති. මෙයා කොන්ස්ටන්ට් වෙලොසිටිස් වලින්ම යනවා. හැබැයි කොහොමද යන්නේ? යුනිෆෝම් වෙලොසිටි එකකින් යනවා කියන්නෙම එයාට රිසල්ටන්ට් එකක් තියනවද? නැත. පළවෙනිම පොයින්ට් එක. If it is moving with a uniform velocity, V, it has no resultant force, right? It means if there is a force to this direction called F, it is balanced by the friction F. Therefore, no resultant force. හරිනේ. ඕක තමයි uniform velocity වල first කතාව. ඕක අපි දැනගෙන ඉන්නේනේ. පොඩි කෙනෙක් වුණත් දන්නවා, ඕලෙවල් කරද්දිත් දන්නවා. Uniform velocity කියද්දි මොකද්ද කතාව? There is no resultant force. ඒක නිසා මෙතන forces තියෙනවා. හැබැයි there is no resultant force. But if it is acted by an unbalanced force, it will try to accelerate or retard. හරිනේ. accelerate වෙන්නත් පුළුවන්, retardate වෙන්නත් පුළුවන්, decelerate වෙන්නත් පුළුවන්. හැබැයි unbalanced force එකක් act වෙනකම් මේ කිසිම දෙයක් වෙන්නේ නැහැ. ඕක තමයි පළවෙනි දේ. හැබැයි දැන් ඕක නෙමෙයි කතාව. ඇත්තටම මට එන්න ඕන කරන ඕක නෙවෙයි. ටියුට් එකේ දීලා තියෙනවා it is also often referred to as Newton's law of inertia. ඕක තමයි ඇත්තටම මේකේ ස්ටෝරි එක. law of inertia. inertia කියලා කියන්නේ මොකක්ද? inertia idea එකක් තියෙනවා. no. inertia කියලා කියද්දිම මතක් වෙන්න ඕන laziness. පැහැදිලිද? inertia කියන්නේම laziness. දැන් අපි උඹලා වගේම තමයි මෙන්න මේ matter කියන જાතියත් ඇත්තටම එයා ඉන්න ස්ටේට් එක මාරු කරන්න මාර අකමැති. හරිද? ඒ කියන්නේ එයා ඉන්න ස්ටේට් එක මාරු කරන්න පට්ටම අකමැති. අපි බලමු ඒ කියලා. දැන් මම බ්ලොක් ඔෆ් මෑස් එකක් ගන්න. මෙන්න මෙහෙම M බ්ලොක් එකක් ගන්න. හරිද? එතකොට මෙන්න මේ බ්ලොක් එක මේ විදිහේ සර්ෆේස් එකක තියෙනවා. දැන් හිතන්න මම දැන් මෙයාට පොඩි ෆෝස් එකක් දෙනවා මෙන්න මේ ඩිරෙක්ෂන් එකේ. මෙන්න මේ ඩිරෙක්ෂන් එකේ මෙන්න මෙහෙට ෆෝස් එකක් දෙනවා F කියලා. මම දැන් පොඩි ෆෝස් එකක් දුන්නා කියලා මෙයා මූව් වෙන්න ගන්නවද? ගන්නවද? නැහැ. මූව් වෙන්න ගන්නෙ නැහැ. හේතුව මොකද්ද? මෙයාගේ මේ තියෙන මෑස්. හරිනේ. එතකොට නිකන් හිතන්න මම දැන් ගන්නවා තඩි කන්ටේනර් පෙට්ටියක් වගේ. දැන් කන්ටේනර් බොක්ස් එකක් අරගෙන අපි කොච්චර තල්ලු කරන්න හැදුවත් තල්ලු වෙනවද? නැහැ. What is the reason? It has a greater mass. හරිද? ඕකට අපි කියනවා laziness of matter කියලා. මම දැන් inertia කියන එක ටිකක් හොඳට එක්ස්ප්ලেইন කරනවා. වැඩේ අන්තිමේට යද්දි තේරෙනවා. තාම ලොකු අයිඩියා එකක් නැහැ. මම දන්නවා. හරි. එතකොට ඒ කියන්නේ අපි ෆෝස් එකක් දුන්නාම මේ ෆෝස් එක මෙන්න මේ මෑස් එකෙන් හදන inertia එකෙන් resist කරන්න බලනවානේ. එතකොට අනිත් එක අපිට තේරෙනවා when the mass increases inertia increases. හරිනේ. when the mass is increasing inertia increasing. අපිට දැන් මෙහෙම හිතන්නකෝ. මම දැන් බයික් එකක් කරගෙන පයින් පාරක් ගහනවා. බයික් එකක් කරගෙන පයින් පාරක් ගැහුවොත් ඒක කඩාගෙන යනවා මෙහෙට. දැන් කෝච්චියකට ගිහිල්ලා පයින් පාරක් ගැහුවොත් ට්‍රේන් එකකට ගිහිල්ලා පයින් පාරක් ගැහුව කියන එක වැඩක් නැහැ. ඇයි? train has a higher inertia. තේරුණාද? එතකොට මෙන්න මේ නිව්ටන් වලදී දැන් ඔයාලා ගොඩක් දෙනෙක්ට inertia කියන එක ඔළුවේ තියෙන rotational motion එක. නේද? මං හරියද? ඒ ඇවිල්ලා වෙන inertia, moment of inertia. මේ කතා කරන්නේ inertia කියන concept එක ගැන. එතකොට same තමයි ඒ වුණාට use වෙන application එක වෙනස්. එතකොට inertia කියන එක අපිට ලියන්න පුළුවන් inertia of an object directly proportional to its mass. තේරුණාද? inertia of an object directly proportional to its mass. කතාව හරිනේ. හරි. දැන් මෙහෙම කරමු. දැන් මෙන්න මෙහෙම notation එකක් තියෙනවා. ඕක මම කිව්වේ නෑ කලින්. මෙන්න මේක maths කරන අය නම් දන්නවා. මොකද්ද? sigma f. මොකද්ද sigma f කියන්නේ? Sum of all forces. It means it is equal to resultant force. හරිනේ. ඕක දැන් දන්නේ නැති අය ඉන්න හින්දා තමයි මම කිව්වේ ඒක දැන් කතාවට අදාළත් වෙන්නේ. හරි. දැන් එන්නකො අපේ කතාවට. හරි. අපි බලමු page number 1 එකේ. කියලා තියෙනවා resultant force. If the force acting on an object is balanced, a stationary object remains stationary. ඒ කතාව හරි. Point 1 එක අපි දාමු. Object continues to move at constant speed in same direction. ඒ කතාවත් හරි. අපි ඒ ඔක්කොම කරමු. එතකොට at rest එකේ තියෙද්දි මොකද්ද වෙන කතාව මෙතන? දැන් inertia කතාවත් අපේ පොඩි idea එකක් තියෙනවා. දැන් rest එකේ ඉද්දි මොකක්ද වෙන්නේ? අපි මේකට unbalanced force එකක් දෙන්නේ නැහැ. හැබැයි මේකේ forces තියෙනවා. මොනවද forces? It has the weight, its own weight, mg, and other force, the normal reaction by the surface. ඔය කතාවට අපි පස්සේ එනවා. දැනට normal reaction by the surface on the body. එතකොට අපි මෙහෙම උඩින් මේසයක් උඩින් ඔබ්ජෙක්ට් එකක් තිබ්බොත් එයා උඩ යනවද? බිමට කඩාගෙන බහිනවද? නැහැ. ඒ කියන්නේ මොකක්ද ඒකේ reason එක? R equal to mg. So is there any resultant force? No. So in this direction or in this direction, is there any resultant force? No. So sigma f horizontal is also equal to 0. So this is at rest. එතකොට velocity එකකින් යන movement එකක් consider කරත් v කියන constant velocity එකකින් යන movement එකක් consider කරත් මොකද්ද කතාව? මේකේ forces balanced. horizontal forces 0 කියන්න පුළුවන්ද? මෙතන බෑ. rest එකේ ඉන්නවනම් 0. හැබැයි මෙතනදී horizontal forces තියෙන්න පුළුවන් මෙහෙට F කියලා force එකක් තියෙද්දි මෙහෙට frictional force එක F තියෙන්න පුළුවන් F equal F cancel out. No resultant force and also R equal mg. ඔය condition එක උතෙන්ටත් වැඩි. right. ඊළඟට අපි කතා කරන effects of a force. දැන් හිතන්න මෙහෙම කතාවක්. අපිට මෙන්න මෙහෙම mass එකක් තියෙනවා. අපි හිතමු ෆුට්බෝල්. හරිද? ෆුට්බෝලෙන් මෙතෙන්ට පටෝන් ගාලයක් ගහනවා. කකුලෙන් ගහනවා. අපි කික් එකක් ගහද්දී මොකද්ද වෙන්නේ? What happens next? It is starting to move in this direction. So with a force we can initiate a motion. අපිට motion එකක් පටන් ගන්න පුළුවන්. තව ෆුට්බෝල් එකක් දැන් මේ ඩිරෙක්ෂන් එකෙන් එනවා අපිට. ෆුට්බෝල් එකක් එනවා මෙන්න මේ ඩිරෙක්ෂන් එකෙන්. අපිට පුළුවන් නේද මෙන්න මෙයාව මෙහෙට ෆෝස් එකක් දීලා මෙයාව ස්ටොප් කරගන්න. හරිනේ? එතකොට we can stop or terminate a motion. Right? And also අපි හිතමු ෆුට්බෝල් එක දැන් මේක ෆුට්බෝල් එක අපි උඩින් බලනවා. හරිද? නිකන් අර ඩ්‍රෝන් view එක ගන්න. එතකොට ෆුට්බෝල් එක මෙහෙට එන්නේ. මෙහෙට આવොත් අපි ඕකට මෙන්න මේ පැත්තට ෆෝස් එකක් දුන්නොත් මු කොහෙටද යන්නේ? මෙහෙට නෑ. මුගේ මෙහෙට ඉනිෂියල් මෝෂන් එකක් තියෙනවා. එතකොට මම මෙහෙට ෆෝස් එකක් දෙනවා. එතකොට මේක මෙන්න මේ වගේ සයිඩ් එකකට යන්න ගන්න. හරිනේ? Why this is moving in this direction? මෙන්න මෙහෙනුත් ෆෝස් ඉනිෂියල් වෙලොසිටි එකක් මෙහෙට තිබ්බා. දැන් මෙහෙට ෆෝස් එකක් හම් වෙන්නේ. එතකොට මෙයාව මෙහෙට යන්න ගන්නවා. මාර ප්‍රැක්ටිකල් නේ. හරි. So it can change direction. And also finally if a block is moving, if a ball is moving to this direction, මං ඒකටම ගිහලා පිටිපස්සේ පයින් පාරක් ගහනවා මෙහෙට. මොකද වෙන්නේ? Change the magnitude. හරිනේ. force එකකින් අපිට මෙන්න මේ දේවල් හතර initiate කරන්න පුළුවන්. start a motion, stop a motion, change the magnitude of velocity, change the direction of velocity. note එකක් දීලා තියෙනවා if the resultant force is 0, none of the changes will occur. හරිනේ. අපිට resultant force එකක් තිබුණොත් විතරයි ඔය කතාව ගොඩ දාගන්න පුළුවන්. හරි. next අපි කතා කරපු අර මම පොඩියට කතා කරපු topic එක. inertia. එතකොට මේක තමයි මේ නිව්ටන් වල තියෙන පොඩ්ඩක් බෝරින් හරිය. මේක අල්ලන් ඉන්න. ඊට පස්සේ ගණන් හදද්දි මේකේ ෆන් එකක් තියෙනවා. හරිද? අමුතුම මේකක් තියෙනවා. ඒක නිසා මේ වීර එක කොහොම හරි අල්ලගෙන ඉන්න මේක හරියට අල්ලගත්තොත් ගණන් හදන එක ලේසි. ගොඩක් අය නිව්ටන් සෙකන්ඩ් ලෝ එකෙන් පටන් අරගෙන F equal මේ දාලා ගණන් හදන්නේ නැහැ. මේ inertia ඔය වගේ concept නැතුව ඇත්තටම ගණන් හදන්න බෑ. හරිනේ? හරි. දැන් inertia එක ගැන කතා කරද්දී මම කිව්වා inertia is directly proportional to mass. ඔය දල අවබෝධය අපිට තියෙනවා නේ. පොඩි understanding එකක් තියෙනවා. Inertia is always directly proportional to its mass. හරි. ඒ කතාව හරි. එතකොට මට කියන්න මම කලින් කිව්වා if I hit a train will it move? No, it will resist the motion. හරි. එතකොට මම ෆුඩ් බයික් එකකට පයින් යද්දී කිව්වොත් ඒක පොඩ්ඩක් හරි යනවානේ. ඇයි? It has a lower inertia. හරි. ඒ කතාව ඔළුවේ තියෙනවා. එතකොට දැන් මේකේ මෙහෙම සීන් එකක් තියෙනවා. නිකන් එක්ස්පීරියන්ස් කරලා තියනවාද? You are moving in a vehicle in a road like this. හරිද? You are moving in a road like this in a car. හරි. මෙන්න මෙහෙම කාර් එකක් තියෙනවා. And there is a bend. හරි. මෙන්න මෙහෙම බෙන්ඩ් එකක් තියෙනවා. එතකොට අපි මෙන්න මෙහෙම ගිහිල්ලා මේක හරවන්න ගද්දිම කොහෙටද අපි ඇදලා යන්නේ? මෙන්න මේ ඩිරෙක්ෂන් එකට ඇදලා යනවා. තේරුණාද? කවුරු හරි ඇවිල්ලා අපිව අදිනවද? නෑනේ. ඒක තමයි කියන්නේ. දැන් මොකක්ද උනේ? දැන් මෙන්න මේ අපි ඉන්නේ මෙතන ඉන්නේ මම. හරිද? මම කියන්නේ මැටර් එකක් නෙනේ. මැටර් එකක් හැමතිස්සෙම කම්මැලි. හරි. It has inertia. It means it is lazy. හරි. එතකොට මේක හුරු උනේ මොනවා කරන්නද? මේක හුරු වෙලා ඉන්නේ constant velocity එකකින් ඉස්සරහට කඩාගෙන යන්න. හැබැයි දැන් මෙතනදී මොකද කරන්නේ? වාහනේ අපිව මෙහෙට හරවන. ඇඟ කැමතිද ඒකට? නෑ. ඌ කියන්නේ මට මෙහෙටම යන්න ඕන කියලා. හැමතිස්සෙම අපේ ඇඟ කියන්නේ මොකද්ද? මට කෙලින් යන්න ඕන. තේරුණාද? So there is a force by inertia to this direction. තේරුණාද? To this direction there is a force by inertia. අපේ ඇඟෙන් මෙහෙට force එකක් දෙනවා. ඒ කියන්නේ ඇයි? එයා change එකට කැමති නෑ. පැහැදිලිද? හරි. එතකොට inertia is the property of an object resist any change in its state of rest or uniform motion. It is the laziness of matter. කතාව හරිනේ. හරි. මොන දේ කරන්නත් ඌ කැමති නෑ. එච්චර. හරි. ඊට පස්සේ relationship with mass. අපි කතා කරා low mass කියන්නේ මොකද්ද? low inertia. higher mass කියන්නේ higher inertia. ඒතර low mass එකට example එකක් දීලා තියෙනවා tennis ball. ඊට පස්සේ high mass එකට heavy mass එකකට දීලා තියෙනවා loaded truck. right. හරි. දැන් එනවා මාරම important section එකකට. මේක ඇත්තටම ෆිසික්ස් වලට ඔය B එකක් ගන්න එකටවත් බෑ. හරිද? ඒ වුණාට දැන් මේක උපරිම තේරුම් ගන්න පුළුවන් මාරම ලේසි සුට්ටක් කොමනාවෙන් අහගෙන ඉන්නවා. හරිද? හරි. frames of reference. frames of reference. frames of reference. හරි. දැන් ඔය නිව්ටන් කියන ඩයල් එක අපි හිතුවට මේක දැන් මේ F equal ma විතරයි කියලා ඕක පිටිපස්සේ ලොකු ස්ටෝරියක් තියෙනවා. හරිද? නිකම් නේ ඇපල් ගෙඩියක් ඔලුවට වැටුණ පළියෙන් මේවා ආවේ නැහැ. හරිද? එතකොට එයා කියන පළවෙනි සීන් එක තමයි there are two frames of reference. first frame මොකද්ද? මොකද්ද first frame එක? inertial inertial මේ initial නෙවෙයි inertial frame of reference. හරිද? තාම මුකුත් තේරෙන්නේ නැහැ අහගෙන ඉන්න. ඊට පස්සේ non inertial frame of reference. ඕක තමයි කතාව. හරිද? දැන් මේකයි සිහින්. දැන් හිතන්න මෙන්න මෙහෙම එකක්. දැන් මෙන්න මෙහෙම කා එකක් තියෙනවා. මෙන්න මේ කායකට මෙහෙට ෆෝර්ස් එකක් දෙනවා F නිව්ටන්ස්. හරිද? එතකොට එයාට මෙන්න මෙහෙට රෙසිස්ටන්ස් එකක් තියෙනවා due to friction. think it is as a constant resistance. හරිද? මොකක් හරි ටයර්ස් වලින් රෙසිස්ටන්ස් එකක් තියෙනවා. let me take it as R and mass of the object M. හරි. දැන් හිතන්න ඕන මෙයා move වෙන්නේ මොකක් උඩද? කා එකක් යන්නේ මොකක් උඩද? on the road. So in physics we treat the earth as a stationary object. තේරුණාද? always earth is at rest. හරිනේ? හරි. එතකොට earth එක rest එකේ තියෙනවා. එතකොට මොකද අපි කරන්නේ? කෙලින්ම මෙයාට F equal ma apply කරන්න පුළුවන්. we can apply F equal ma in a specific direction. F equal ma is a vector. F is a vector, force is a vector. So you have to apply the equation in a specific direction. So I can apply in this direction. So F minus R equal to mass times acceleration. You can obtain acceleration to be F minus R divided by m. This is the acceleration. Got it? Hi. Then අපි මේක දන්න දේ. මේක අමුතුවෙන් කියලා දෙන්න ඕන දෙයක් නෙවෙයි. හැබැයි දැන් මෙහෙම සිටුේෂන් එකක් ගන්නකො. මම දැන් පෙන්ඩියුලම් බොබ් එකක් මෙන්න මෙහෙම එල්ලලා තියෙනවා. පෙන්ඩියුලම් එක දන්නේ නැත්නම් නිකන් බෝල් එකක් කියලා හිතන්න. මෙහෙම එල්ලලා තියෙනවා. මේක මෙන්න මෙහෙමනේ තියෙන්නේ. හරිනේ මම? හරි. මේක මෙහෙම තියෙනවා. හරි. මේකේ මොනවද ෆෝර්සස් එන්නේ? උඩට ටෙන්ෂන්, යටට mg. මෙතන මොනවද වෙන්නේ? T equal mg. This is at a ceiling. හරි. ceiling එකක් කියන්නේ මොකද්ද? rest එකේ තියෙන object එකක්. දැකලා තියෙනවද මෙන්න මෙහෙම scene එකක්. මාරු වමනාවෙන් අහගෙන ඉන්න මේක තේරුණා කියන්නේ සුපිරිය. මෙන්න මෙහෙම එකක් දැකලා තියෙනවා. අපි vehicle එකක ceiling එක ගන්නවා. හරිද? මම ඕකේ මේක එල්ලුවොත් මෙන්න මේක මෙහෙම තියෙනවද? නෑනේ. දැකලා තියෙනවනේ අර කායක එකපාර ඇක්සලරේට් වෙලා යද්දි ඕක කොහෙටද යන්නේ? පස්සට යනවනේ. කායක එකපාර ඇක්සලරේට් කරද්දි වෙන කාය is accelerating, we also move downwards, we also move backwards, right, towards the seat. එන්නේ ඒ වගේ මෙන්න මේක මෙහෙම තියෙන්නේ. එතකොට ඒක කොහොමද තියෙන්නේ? මෙන්න මෙහෙම when it is moving in this direction. පැහැදිලිද? හරි. දැන් මේකයි කතාව. දැන් මෙයාගේ weight එක act වෙන්නේ කොහෙටද? mg downwards. Say tension in this direction. දැන් අපි මෙහෙම කරනවා. හරි. දැන් මේක ඇවිල්ලා accelerating frame එකක් නේද? මම දැන් vehicle එක consider කරොත් මෙන්න මේ full frame එක, this is a accelerating frame to this direction. තේරුණාද? හරි. මම දැන් consider කරොත් මෙන්න මේ situation එක, is this a accelerating frame? No, this is a frame at rest. හරි. දැන් මම ඉන්නවා මෙතන. හරිද? මාරු වමනාවෙන් අහගන්න. ආයේ මමත් ඉන්නවා මෙතන. හරිද? එතකොට මම කරනවා මොකද්ද? මම මෙතන ලියනවා T equal mg. හරිද? ඔක ලියාගත්තා. එතකොට දැන් මම බලනවා මම එක තැනකින්දි මේක තිබ්බේ මෙහෙම. තව තැනකින්දි මේක තියෙන්නේ මෙහෙම. මොකද්ද කතාව? ඒ කියන්නේ අපිට පුළුවන්ද මෙන්න මෙතන මේ කෙනා වෙලා කෙලින්ම මෙයාට ඉක්වේෂන්ස් දාන්න? බෑ. හරිද? ඇයි මොකද්ද කතාව? දැන් මේක රෙස්ට් එකේ තියෙන එක. අපිට කෙලින්ම ඉක්වේෂන් එක මෙයාට දාන්න පුළුවන්. හරිද? But this has an acceleration to this direction. There are forces created due to acceleration. හරිද? හැබැයි අපිට ඒවා පේනවද? නැහැ. ඇයි ඇත්තටම මේක මෙහෙට ගිහිල්ලා තියෙන්නේ? මේක මෙහෙට ගිහිල්ලා තියෙන්නේ අර ඇක්සලරේෂන් එක නිසා මෙහෙට ෆෝර්ස් එකක් හැදිලා තියෙනවා. තාම තේරෙන්නේ නැහැ ඇයි මේක හැදුනේ? ඇයි මේක මේ ඩිරෙක්ෂන් එකට හැදුනේ? තාම ඉන්නේ. හරි. එතකොට මේක මෙහෙම පේන්නේ ඇයි? කොහෙට හරි ෆෝර්ස් එකක් හැදිලා තියෙනවා. හරි. අනිවාර්යෙන් බෑක්වර්ඩ් නේ. හරි. එතකොට අපිට පුළුවන් ද නිකන් මෙතන ඉඳගෙන මෙයා කරන වැඩේම අපිට මෙතන ඉඳන් කරන්න පුළුවන්. මෙන්න මේක ගණන් ගන්න නැතුව. බෑ. ඕක තමයි ගොඩක් අය වරද්ද ගන්න තැන. අපි හිතමු ලිෆ්ට් එකක යනවා කියලා. ඒතකොට ලිෆ්ට් එකක යද්දි අපි දැන් ගොඩක් ෆිසික්ස් උගන්වන සර්ලා කරන්නේ ලිෆ්ට් එක උඩට යද්දි a+g ඇක්සලරේෂන් එකනේ. යටට එද්දි g - a. එතකොට ඕකනේ කතාව. ඒක නෙවෙයි මල්ලි කතාව. ඒ කියන්නේ මේකේ සීන් එක වෙන්නේ මේක කොහොම හරි ඔලුවට දාගන්න ඕන. එතනින් පස්සේ එන ගොඩාක් ගණන් හදන්න පුළුවන්. හරිද? ඒක නිසා දැන් මේක ඔලුවට දාගමු ටක් ගන්න. එතකොට මේ ෆෝර්ස් එකක් තියෙනවා අපි ඒක දන්නේ නැහැ. හැබැයි අපි එකක් දන්නවා මොකද්ද? We cannot apply F equal ma. F equal ma directly apply කරන්න පුළුවන් ද accelerating frame එකක් ඇතුළේ ඉඳගෙන? බෑ. හැබැයි rest එකේ ඉන්න frame එකක් ඇතුළේ ඉඳගෙන පුළුවන්. හරිනේ. හරිනේ? හරි. එතකොට අපි මොකද කරන්නේ? දැන් මෙහෙම හිතනවා. දැන් හිතන්නකෝ මම අර inertia කියලා කිව්වේ මොකද්ද? අකමැත්තනේ, laziness. So අපි හිතනවා vehicle එක rest එකේ ඉන්නවා. rest එකේ ඉද්දි මෙන්න මෙයා කොහොමද ඉන්නේ? මෙන්න මෙහෙම. හරිනේ. vehicle එක එක්ක rest එකේ එහෙම නැත්නම් moving with constant velocity no resultant force or no acceleration හරිනේ එතකොට මෙන්න මේ position එකේ ඉන්නේ එතකොට අපි accelerate කරද්දිනේ මෙයා මෙන්න මෙහෙම මෙහෙට move වෙන්නේ නේද හරි ඒ මොකද්ද වෙන්නේ දැන් vehicle එක කියනවා යන් කියලා move කියනවා බෑ කියලා තේරුණාද ඇයි this has a inertia this has a weight this has a mass so if it has a mass it has a inertia means laziness මූ කැමතිද ඉස්සරහට යන්න ඌ කැමති නැහැ ඌ කැමති නැත්තම් ඌ try කරන්නේ මොකද එහෙම ඉන්න මෙයා මෙහෙම ඉන්න try කරනවා මෙයා මෙහෙම ඉන්න try කරද්දී මේ frame එක මොකද වෙන්නේ ඉස්සරහට යනවා පැහැදිලිද so ඒක නිසා මෙන්න මෙයා මෙහෙට F කියලා force එකක් හදා ගන්නවා F කියන්නේ කීයද mass times මෙන්න මේ frame එකේ acceleration එක මෙන්න මෙයාගේ mass එක times මෙන්න මේ frame එකේ acceleration එක මේකට අපි කියන්නේ මොකද මේක අපිට පේන force එකක්ද නෑ එතකොට මේකට අපි කියන්නේ මොන force කියලාද pseudo force කියලා එහෙම නැත්නම් force by inertia මේක inertia එකෙන් හැදෙන force එකක් අපිට පේනවද නෑ හැබැයි දැන් කර හැකි දැන් මෙයාට F ma apply කර හැකි මේ force එක ගැන හිතලා අපි බලමු එතකොට මෙයා කොහොමද F ma apply කරන්නේ F ma to this direction මෙහෙම ගත්තොත් මේක මම ගන්නවා theta කියලා so t cos theta minus ma equal to what t cos theta minus ma equal to what ma ඔය වගේ කතාවක් එන්නේ හරිද දැනට ඔළුවට ගිය දේ මේක ඔළුවට දාගන්නකො මේ කතාව පොඩ්ඩක් පැත්තකින් තියෙන දැනට ඔළුවට දාගන්න ඇයි මේක මෙහෙම වෙන්නේ කියන එක ඉනර්ෂියා කියන්නේ මොකක්ද ඉනර්ෂියා කියන්නේ මොකක්ද මේක පිටිපස්සට අදිනවා කියන එක නෙවෙයි මොකක්ද ඉනර්ෂියා කියන්නේ යන්න කැමති නෑ යන්න කැමති නැත්තම් මූ මෙතන ඉන්න නේද කැමති ඉන්න කැමති නිසා මෙයාව පිටිපස්සට ඇදලා තියෙනවා පැහැදිලිද එතකොට මේකට අපිට එකපාර මෙතන ඉඳන් දාන්න පුළුවන්ද බෑ හැබැයි අපිට පුළුවන් එළියේ ඉඳලා directly F equal ma apply කරන්න. ඕවාලා ගණන් තියෙනවා ඉස්සරහට මම ඕවා කියලා දෙනවා. ඒක නිසා දැනට මේ කතාව තේරුණාද? ඔව්නේ. හරි. මෙයා ඇයි මෙහෙට යන්නේ? inertia එක නිසා inertia එක කැමති නැහැ ඉස්සරහට යන්න. So it gives a force to this direction which is ma. We call that force to be pseudo force or force by inertia inertial force කියලා අපි කියනවා. right centrifugal කතාව වෙන්නේ rotation මේ circular motion එක. ඒක එතනදී අපි කරමු. හරිනේ. ඒකත් inertial force එකක් තමයි. ඒක අපිට පේන එකක්ද? නෑ. ඒකත් inertial force එකක්ම තමයි. right. අපිට එතකොට frames of reference වල කියලා තියෙනවා. An inertial frame of reference is a frame that is not accelerating. හරි නේද? It is not accelerating. So we can apply F equal ma directly. හරිනේ. So Newton's law of motion are strictly valid in these frames. හරිනේ. Second, non-inertial frame of reference. Non-inertial frame of reference is a frame that is accelerating. තේරුණාද? It is an accelerating frame. This includes frame at speed up, slowing down or rotating. It means acceleration, deceleration or rotation. Rotation අපි කතා කරන්නේ circular motion, rotational motion වලට ආපහු. Newton's laws of motion like F equal ma do not hold true unless pseudo forces are introduced. හරිනේ. එතකොට නිකම්ම දැන් මට මේක නැතුව ලියන්න පුළුවන්ද මේ ටෙන්ෂන් එකේ කම්පොනන්ට් එක ma equal කියලා? බෑ. පට්ට වැරදි. හරිනේ. එතකොට ඒ කතාව කරන්න බෑ. ඇයි කරන්න බැරි? ඔය වගේ ගණන් ටිකකට අපි ඉස්සරහට එනවා. දැනට තේරුම් ගන්න ඕන. මේක මෙහෙම ඉන්නේ ඇයි? ඉනර්ෂියා එක නිසා මූ කැමති නෑ යන්න. මූ ඒක නිසා පිටිපස්සට ගිහිල්ලා දෙනවා. මූ ඉස්සරහට යනවා. ඒක නිසා අපි කන්සිඩර් කරනවා මෙහෙට F කියලා pseudo force එකක් තියෙනවා. We can't see that force. ඒ ටික පැහැදිලිද? ඒ ටික පැහැදිලි නම් අපිට ඉස්සරහට යන්න පුළුවන්. හරි. මම අර අන්තිමේට කියපු දේ ගැන වැඩි හිතන්න යන්න එපා. හිතේ තියාගන්න ඕන මොකද? inertial frame කියලා එකක් තියෙනවා, non inertial frame කියලා එකක් තියෙනවා. එතකොට inertial frame කියන්නේ not accelerating, not retarding, not rotating. එතකොට accelerating, retarding, rotating වලට මොනවද කියන්නේ? non inertial frames කියලා. නිව්ටන්ස් ලෝස් දාන්න පුළුවන් මොනකටද? inertial frames වලට විතරයි. හරිනේ. non inertial වලට දාන්න හැටි අපි අන්තිමට කතා කරමු. හරිනේ. දැනට එහෙම එකක් තියෙනවා. එච්චරයි. හරි. Next, we are moving into Newton's second law of motion. හරි. second law එකේ දැන් මේකනේ ඔයාලා ආසම පාර්ට් එක නිව්ටන්ස් ලෝ කියපුවා F equal ma. ඇත්තටම මේක F equal ma කියලා කවුරුත් කියන්නේ නැහැ. හරිද? නිව්ටන්ස් second law කියන්නේ මොකද්ද? මොකද්ද? definition එක. කියවන්න බලන්න. The rate of change of linear momentum of a body is directly proportional to the applied resultant force. හරිනේ? හරි. ඒ කියන්නේ මෙන්න මෙහෙම සීන් එකක්. අපිට ඔබ්ජෙක්ට් එකක් තියෙනවා u කියලා velocity එකකින් යන. හරිද? අපි ඔය යකාට force එකක් දෙනවා. මෙන්න මෙහෙට force එකක් දෙනවා. අපි හිතමු F කියලා. ඊට පස්සේ ඕක දුන්නට පස්සේ මේක යන්න ගන්නවා කියන්නේ v කියලා velocity එකකින්. in a t time. delta t time period. හරිද? එතකොට නිව්ටන් කියන්නේ the force is directly proportional to rate of change of linear momentum. මම නෙමෙයි කියන්නේ නිව්ටන්. ඔයාලට ඒක හිතන්න පුළුවන්ද? බෑ. මට හිතන්න පුළුවන්ද? බෑ. ඌ කිව්වා අපි ලිව්. එච්චර. හරිනේ. එතකොට හරියට ඔළුවේ තියාගන්න මේක මොකද්ද F equal ma ද නැත. F equal ma මේකෙන් එනවා derive වෙනවා. හැබැයි මෙන්න මේ equation එක you have to keep that in mind. Right. So F is directly proportional to rate of change of linear momentum. Linear momentum කියන්නේ මොකද්ද? mass times velocity. ඒක O level නේ. මේකත් බැරනවා. යන්න. හරි. mass times velocity. So rate of change. change කියද්දී මම linear momentum p කියලා ගන්නවා. සාමාන්‍යයෙන් අපි linear momentum වලට p කියන notation එක use කරනවා. එතකොට p final අපි හැමතිස්සෙම change එකක් ගන්නේ final එකෙන් initial එක නේ subtract කරන්නේ. So p final minus p initial divided by time නේද rate එක ගන්න. rate එක ගන්න හැමතිස්සෙම divide by time. So p final minus p initial divided by time. ඔන්න ඕකට මේක proportional කියලා තමයි නිව්ටන් කියන්නේ. හරි. නිව්ටන්ම හොයා ගන්නවා අපිට පුළුවන් මොකද proportionality අයින් කරන්න constant එකක් දාන්නනේ. ආවව දන්නවා. පොඩි කාලේ. 28 පන්තියට යන්න පුළුවන් දන්නේ නැත්නම්. k times p final minus p initial divided by time. නිව්ටම කියනවා මෙන්න k කියන්නේ 1 කියලා. හරිනේ. k කියන්නේ 1 කියලා ඌ experiments කරලා prove කරගත්තා. හරි. හරි. එතකොට දැන් මේ p final කියන්නේ කවුද? ඒතර k1 කියන එක අපි උතනින්ම දාගමුකෝ. ඒක ඉවරයිනේ එතකොට. p final කියන්නේ කවුද? m v නේද? හරිනේ. mass times final velocity minus p initial m u divided by time equal to force. හරිනේ. එතකොට දැන් අපිට මොනවා කරන්න පුළුවන්? m එක එළියට ගන්න. factorize කරපුවම m එක අපිට ලියන්න පුළුවන් m times v minus u divided by time. හරිනේ. එතකොට v minus u over t. මතකද මේක? මොකද්ද? acceleration එක කියන්නේ මොකද්ද? delta v divided by delta t කියන්නේ change in velocity divided by change in time. හරි. එතකොට delta t කාලයකදී velocity change එකෙන් අපිට acceleration එක ගන්න පුළුවන්. We can find acceleration. So v minus u over t කියන්නේ මොකද්ද? Change in velocity divided by time. So this is equal to acceleration. So we can write what? F equal m a. මෙන්න මේක derive වෙන්නේ මේකෙන්. තේරුණාද? හැබැයි මෙන්න මේක ඔළුවේ නැත්තම් මම වන්න එකත් අයින් කරන්නම්. මෙන්න මෙයාව ඔළුවේ නැත්තම් ගණන් හදන්න ගොඩක් ඒවා බැරි වෙයි. හරිද? මෙන්න මේක එච්චරටම වැදගත්. ඉතින් මේකනේ නිව්ටන් කියපු දේ. ඒතර නිව්ටන් කියපු දේ වැදගත් නැතුව අන්තිම එක වැදගත් වෙලා බැහැනේ. මේක ඕන. අපි direct apply කරන්න පුළුවන්. හැබැයි final velocities initial velocities වලින් යද්දී මෙන්න මේ linear momentum කතාව පට්ට වැදගත්. තේරුණාද? So what is Newton's second law? කටපාඩම් කරන්න ඕනේ නැහැ. එහුවොත් මොනවද ලියන්නේ? the resultant force is directly proportional to the rate of change of velocity, linear momentum, right? Okay. So, we are moving into an important topic. Before that, yes, it is given in the tutorial. Okay. There is a topic, key characteristics. Direction. Acceleration always occur in the same direction as the resultant force. So what it is saying? Acceleration. Acceleration is always in the same direction of the resultant force. Resultant force එකේ පැත්තට නේද acceleration තියෙන්න ඕන. Acceleration must be in the direction of resultant force. ඒක අපිට තේරෙනවා. We can understand that. So mass, no, proportionality, it is saying for a constant mass, acceleration is directly proportional to force. හරිනේ? මොකද්ද හරි කියන්නේ මම? Acceleration equal, මේකෙන් ලියන්න පුළුවන් මොකද්ද? We can write it as F over m. Is it correct? So it is true, acceleration directly proportional to force. And also we can find out acceleration inversely proportional to mass, isn't it? Acceleration inversely proportional to mass. Also we can say, it is said in the tute, for a constant force, acceleration is inversely proportional to mass, or we can say inertia. තේරුණාද? Understood? ඒ කියන්නේ acceleration inverse proportional to mass. Mass is a measurement of what? Inertia. Why? Inertia is directly proportional to mass. So we can clearly write it is acceleration is inversely proportional to inertia also. Got it? වැඩේ පැහැදිලිනේ? Right. Okay. So F equal ma, they have derived in the tutorial. They took k equal 1. The constant we took here, it is equal to 1. Right. Okay, it is an important point. The equation F equal ma is a vector equation. It must be applied to a specific direction at a time. Specific chosen direction at a time. Can we apply F equal ma in any direction? Yes, we can apply, but we have to be careful of the specific direction. But if we apply in this direction, only this direction forces should be positive. If there are forces in this direction, I mean, this is F1 and this is F2. We have to consider we are applying equation in this direction. We can apply equations inclined. සමහර හිතනවා if equal m apply කරන්න පුළුවන් මෙහෙටයි විතරයි කියලා. එහෙමද? එහෙම නෙවෙයි. We can apply in this direction, and also in any direction. It doesn't matter. But when you are taking resultant forces, F1 in this direction minus F2, we are coming to in this section. Right. Okay. And there is another topic. No, another point. In the light inextensible string, the magnitude of tension is same at each point. මොකද්ද කියන්නේ? Let me take a light inextensible string. This is a light inextensible string connected by two bodies. Sorry, two bodies are connected by a light inextensible string. It is like this. All right. So what is happening? I take this as M1. This is M2. Right. I'll take it as an example also. I am applying a force of F to this direction. I'm applying a force of F to this direction. What is given in the tute? In a large light inextensible string. Light means it has no mass. We do not consider that mass. We neglect that mass. So mass is negligible. Can we take a rope? No, it is not a rope. It is a light inextensible string. Inextensible means it cannot stretch like an elastic. Understood? It cannot stretch. If it is stretching, the tensions will be different. We are not considering like extensible strings in this section. There's a extra section in properties of matter discussing about uh, yes. Now we are moving into that part. If the tension at this point is T, tension we always mark like this. They are facing each other, right? Tensions we mark as they are facing each other, like this. So this tension belongs to this mass. This tension belongs to this mass, right? So what is this? This is also T. Because why? In a light inextensible string, magnitude of tension is equal at every point of the string. Right. I think you got that. Right. What shall we do now? So tell me what is the only force acting on M1? It is T. Someone's are taking, it is same F acting on the M1. Is it correct? No, it is just T, right? On M2, there are two forces F and T. So if I apply F equal ma to this is surely accelerating to this direction. We know that. Right. So if I apply F equal ma to mass m2, what is going to happen? Force means we have to select a direction. So I'm taking this direction because it is accelerating to that direction. This direction. So what is the force? F minus. Why we are taking minus? Because tension is in opposite direction. F minus T equal to M2A. This is the first equation. And we can apply F equal MA to M1 mass to M1 mass. So what can we get in this direction? It is very important. What can we get? T equal to M1A. This is the second equation. Got it? Right. What shall we do now? Add 1 plus 2. Is it right? Tension is this T and this T cancel out. So we can get F equal what? M2A plus M1A. I can factor out A out. M1 plus M2. Is it okay? Right. So we can calculate A equal to F divided by M1 plus M2. It is okay, right? Okay. So what shall we do now to find T? T equal M1 A. We can substitute A to this equation, right? You all know this, right? I don't want to teach these kind of things because you know this, right? Now I'm moving to a pulley system. I'm moving to a pulley system, right? If I consider this as a pulley, right? This is a pulley, and this has special conditions. What are they? It is a massless pulley, massless, and also smooth, right? It has no friction, right? If it is a massless smooth pulley or weightless smooth pulley, this is the situation. So if I apply, if it is a string, the same string, this is M2 mass, and here it is M1 mass. If it is said in the question, M1 greater than M2. So the first thing you have to do in a force system or a block system or anything, what is the first thing you have to do? Mark the forces, right? The forces marker. So here it has tension. Tension has weight M1G. It is the mass M1, so weight is M1G. Right. It has a tension T. Why? This is the same tension, right? This is the same tension. Because this is the same string, right? It is like this, connected to the ceiling, and this is the same string. So what is happening? It is the same tension everywhere, right? It is the same tension everywhere. So, right. So what is this? M2G. So if they ask what are the forces acting on pulley, what are they? It has a force to this direction definitely, right? It has a force to the tension force to this direction, and also tension force to this direction. Is it mandatory to mark those things? No, because we are not applying F equal ma or any equation to pulley at this stage. So is it necessary? No, it is not necessary to apply tensions or forces acting on that pulley, right? We are just considering about the masses. So if I apply F equal ma, what is the direction we have to apply? Because it is said in the question m1 greater than m2. So what is the direction of accelerating? This is the direction of accelerating. This has a higher mass, this has a lower mass. So this is the direction of acceleration, right? This moves upward, and this moves downward. So if I take acceleration to be A in upward direction, what is the acceleration here? It is the same A. If this is moving with A and this is an inextensible spring, can it move with a different acceleration? No, it can't, because this is moving with A and this can't stretch. So it has to move with same A acceleration. So what shall we do? The same thing, because we can apply F equal ma to m1 max. In which direction? Direction is important in downward direction, right? So what is the downward weight? M1G. The downward force is M1G. We have to consider only the forces acting on M1. So upward force, it is G equal to M1A. This is the first equation, right? Then I will apply F equal MA to M2 max. So what is happening then? We have to apply this equation in the upward sense because it is moving in upward direction. So what is the upward force? We have to consider upward forces first. So tension minus M2G. M2G equal to M2A. This is the second force. Get it? Right. What is the thing we have to do now? Add 1 and 2. 1 plus 2. So we can obtain tensions cancel out. When we add tensions cancel out, m1g minus m2g equal to acceleration. I can factorize m1 plus. So what is the acceleration? I will write it here. Acceleration equal to g, we can take it out, m1 minus m2 divided by this m1 plus m2. Did you understand? Right. Is there any questions? Yes, sure. Okay. If you have any questions, you can send to the admin chat, right? Not the chat under my name, because it is under the video. Right. Okay. I think you can understand this. So move on to question number 2 in page number 14. In page number 14, there's question number 2. So do that question. It is very easy question. You can do it. I will erase this one. You have to think the things logically without copy. Right, be quick. We have lots of advanced questions to solve. how to do calculations on moving pulleys. So I will talk about that because we have questions like that. So when we come to those questions, I will teach you, right? We will do those questions in about half an hour, right? To question number two. Don't take time to draw figures very neatly, right? Only the forces have to be clear. So don't waste time on drawing pictures and stuff. Just the free body diagram and perfectly marked forces. That's it. We just apply equations. That's all. Right. I will solve the question. Now enough. So what shall we do now? First of all, mark the forces. 2 kilogram, the weight is 2 into G. It is 20 newtons. And here, the weight acting is 10 newtons. And the tension in this direction, T. Tension in this direction, T. Right. Okay. So, what is the direction it is accelerating? It is accelerating in this direction, right? In this direction. So it is going in this direction because this has a greater weight, and this direction is. So acceleration A. So what shall we do now? Just apply F equal ma, F equal to ma to 2 kilograms to downward direction. This is very important. When you're solving complex problems, this direction is much more important. So downward force 20 minus T equal to the mass is 2 times acceleration. This is first equation. And we are applying F equal ma to 1 kilogram. 1 1 kg. You have to write what is the quantity, what is the block you are applying, what is the thing you are applying. F equal ma, it is to the upward direction. So T, the upward force, you have to take first the T and minus 10 equal to M1 is 1 times A. This is second equation. So the just thing you have to do 1 plus 2. The tensions cancel out. 20 minus 10, 10 equal to 2A plus 1A, 3A. So what is the acceleration? 3.33 ms minus 2. So those who got this correct, please raise your hand. This is the question. Just raise your hand. I need to know whether you understood or not. Others? Right. Okay, fine. So I think you understood the things. This is a basic sum. Even you don't get these types of sums in levels. Right. Okay, so now you have to do question number 3. Question number 3. You have to take to your mind there is a spring balance system, and the reading of this spring is the tension of the string, right? The tension is the reading of the spring balance, and there are two light inextensible strings involved in this question. So think about the tensions, right? To the question. If you can do this question, it is good. To question number 3. You have to solve questions. Without solving the questions and practicing, you cannot even try to do a level sum. Right. Okay. So, shall we discuss this? First of all, right, listen, right. First of all, what you need to do, mark the forces acting, right? If you are asked to mark all the forces, you need to mark all the forces, not just horizontal forces or forces we need, right? If they ask you to mark all the forces, if this is a structured essay or essay question, you have to mark this reaction, R. And also, although it is given as floating in the tute, it is having a reaction R2 to this direction also, right? හරි. ඒක අපිට දැන් වැඩක් නැහැ. We don't want those things. And the weight, here it has a weight of 200 Newton, weight of 50 Newton. And this is the important thing because we have to consider this weight in our calculations. We don't want this weight because reaction is balanced by this weight. So we can't apply F equal ma. We don't want to apply F equal ma in those directions. So what we need to do, I think I'm audible. Right. Okay. So this has a weight of 200 newtons to the downward direction. Right. So tension. This has tension P. And this also has that tension T. Right. This also has that tension T. Got it? Right. So is the tension same here? No. Why? If a single light inextensible string, if there is a single light inextensible string, it has the same tension. So is this a single? No. This is string 1, this is string 2. This is not a single string, so we can't take tensions to be equal. So I am taking this tension to be T1 and this tension to be T2. Right, I think you can understand. So what we are going to do now? Right. Okay, we have different things to do. All right, listen. So we can apply F equal ma to this field in this direction because whole system is moving in this direction, right? Whole system is moving in this direction because only vertical force acting is this 200 Newton. So this 200 Newton pulls all this system downwards to this direction. So the acceleration will take place in this direction and this is also moving with same acceleration as these strings are inextensible, right? Okay, so if equal ma to this direction to this direction to speed. So what is the tension? T2 minus, is there any minus term? No friction, so no minus term equal to what? Mass means 20 times A. This is the first equation, right? If I'm wrong, tell me. Right. F equal ma, we can apply to this one. What is this? This is a spring balance. So I'll apply F equal ma to this direction to spring balance. So if I apply F equal ma, you will get to this direction means we have to prioritize T1 as positive. So T1 minus T2 equal to 5 times acceleration. This is the second equation. Also, we can apply F equal ma to this one. So how we can apply F equal ma? F equal ma to, I'll write it as 20 kg because we wrote this as speed. So in downward sense, because it is accelerating to downward direction, 200 minus T1 equal to 20A. This is the third equation. Right, what we need to do? 1 plus 2 plus 3 because all the terms get cancelled out when we add 1 plus 2 plus 3. Got it? Right. What happened? T2, this T2 plus T2 minus T2 cancel out. Minus T1 plus T1 cancel out. So the remaining terms are just 200. Just 200 is the remaining term. This 20A, 5A, 25A plus 20A, 45A. So you get answer equal 200 divided by 45. 200 divided by 45. The answer is 4.44, isn't it? Yes, answer is 4.44. Right, okay. I have another method to do this. What is that? You can apply F equal ma to whole system, right? You can apply F equal ma to whole system. I haven't teach that yet, but now I'm going to teach that. So there are three objects, right? If I apply F equal ma to whole system, do I need to consider these forces T1, T2? No. Why? They get cancelled out because this T2 force will be cancelled out by this T2 force if I apply F equal ma to whole system. Understood? This T1 force will be cancelled by this T1 force, right? So when we apply equation to whole system, these like forces get cancel out. So do we need to consider those forces? No, surely no. Right. So why we apply F equal limit to the whole system? Because everything is in this system, everything is moving with the same acceleration, right? So I will apply F equal ma to system. F equal ma system. So what is the just force acting when we consider this as a system? It is just 200 Newton. Why? Because this and this can get cancelled out. This and this gets cancelled out. So what is the just force? 200 Newton to downward direction. 200 Newton equal, what is the mass? We have to consider the total mass, right? We are taking F equal ma to whole system. So you need to consider whole forces, right? The addition of whole forces. Then these identical forces get cancelled out. Now you know that. And these two gets cancelled out. The only horizontal, the only affecting force is this 200 Newton. It is there. Then what is the mass we have to take? Is it a mass of object? No, it is the mass of whole system, right? What is the mass of whole system? 20 plus 5 plus 20. It is 45 times A. You get the same answer, right? You get 4.44 ms minus 2 as the acceleration. When you can't apply in some situations are there, you can't apply equations differently. And also it will take time, right? It will take much more time. It will consume much more time because you have to write three equations. You have to write three equations and you have to solve them. Without doing that, we can take this whole thing as a single system and you can apply F equal ma. Got it? Do you have any questions? Just drop to the chat. I think you are okay. Right. So in the next question, they are asking about this reading, right? They are asking about this reading. I will erase this one. So if we think there is an error in this question because they are not mentioning where is the hook, right? Where is the hook, right? I think it is in this direction and uh, it is tied to this string, right? It is tied to this string. So tension will be T1. Keep this in your mind, right? Keep this in your mind. we don't take the resultant of forces when we are dealing with what? Spring balances. It shows just the reading of this side tension. Got it? If we just uh, make an adjustment like this, right? This is a spring balance and it is attached to ceiling. And what will happen? If it is attached to the ceiling, and I will apply a force of mg, right? Mass of m, so the tension will be mg, and it is like here, and it is like here. So the reading will be equal to mg. We know that, ne? Make අවුලක් නැහැ, right? mg, it is equal to tension, and it is equal to force on the spring. Always this measures the force on the spring. We need to consider force on the spring balance. We have to take this in your mind because there are many problems involved in spring balances, right? In any of the sections, there are many problems involving spring balances in many lessons. So you have to learn right now. Spring balance measures the reading of the in the hook, right? What is in the hook? So what is in the hook? T1. T1 is the reading of the spring balance. So you can substitute to third the equation and get the value of T1. So what will be the value of T1? Substitute to third the equation. 200 minus T1 equal to 20 times 4.44. So it is a bit hard to simplify. 200 minus 111, 111.2. Right. You had some important things to learn in that question. So it is a good question. Right. Okay, we are moving to a different section on reactions and come back to questions. Okay. Right. I will erase. If you haven't write down yet, just take a screenshot and write down later. And also you can watch the recording. Hmm? Hmm? Oh, it's more than that. Oh. Right. Okay. So we are going to a different section. Newton's third law, right? Where action, reaction, and those normal reaction, those things come to our mind. Right. Newton's third law of motion. Mega hari prasiddha. This is a famous equation. Not a famous equation. This is a famous saying. Right. What? Every action has a equal and opposite reaction. We all know this. We all know this, and our O-level student also know this. Every action has a equal and right? Every action has an equal and opposite reaction. Hi, listen. Is it just equal and opposite? No, there is a very important thing all of you are going to miss. What is that? Send it to the chat. What is the important thing? Just read the points, key points to understand, and send that to the chat. I can know whether you are actually participating in this. Right. Just send that. What is it? What is the other factor? Equal, opposite. There is a very important thing. Yes. What is the other thing? Quickly, send. Right. Okay. So the other thing is action and reaction acts on two objects, right? Action and reaction acting on two objects. If we consider this, we know this has the weight of the object, isn't it? It is mg. And we know if it is on surface like here, there will be a normal reaction R to this direction, and we know R equal mg, right? We know that R equal to mg. But think it is equal. It is equal. Okay. It is opposite because mg is in downward direction, R is in upward direction. So it is opposite. But is this action reaction pair? Is this action reaction pair? Is this an action reaction pair? No. Why? It violates the third condition, must act on two objects. Must act on two objects in a condition is satisfied when it doesn't satisfy the third condition. So this is a very, very important thing, right? Because in many connections, right? In many questions, there are things asking about this action and reaction. Not just like this, but in many things in A level exam, there is this concept, right? So you have to understand the concept because action reaction means equal, opposite, and acting on two objects. It is very important, right? If I consider this, if I consider this thing, this is a table, right? On a table, what is happening? This has weight mg, right? It is acting in this direction of the table as mg, isn't it? Yes. And if table receives a weight mg, a force mg, then it gives what? A reaction to, I will mark this force in blue because these are the forces in on the table. Forces on the table, I may mark in blue color, it is mg. And if he receives a force mg, he gives a similar force to upward direction to object, and we call that to be what? Normal reaction. So I take it to be W. No? Okay, I'll take it to be W. W. So if I say W and R are action reaction pair, is it correct or wrong? W and R are action reaction pair. I need answers. So send it to the chat. Send it to the everyone chat so I can read. I don't want to read them individually. Now, send. So I'm asking this and this, are they action reaction pair or not? What do you think? Yes. So I'm not getting any answers from online students. What is that? Can't you hear me? Yes. You say yes there. But others, Even a 2028 student is actually participating and responding to questions, right? Okay, so you are 27s and 26. You have to be shame of yours, right? So action reaction pair. Why? Because these are equal in magnitudes, opposite in directions, and what acting on two objects. So that is very important. They must be satisfied. Got it? Right. Good. So that is Newton's third law. Right. We are coming to important section. This is very, very important about tensions. About tensions. Right. Okay. So if we consider like this situation like this, there is the ceiling, and you are hanging a light inextensible string and a block of mass from that. Right. You are hanging a block of mass from a light inextensible string. So what are the forces acting? Tension, T and mg. We know that. And what is the force acting here? It is also tension. Right? It's also tension. So, right, good. So, what is happening now? I need you to answer to this question also. What is that? I am taking this object M. So tell me, is tension belong to object M? Is tension belong to object M? Yes, yes. Online students, is it a yes or a no? Yes. But why we are marking it in the string? We are taking this belong to object M, and we are marking that on the string. I'll take you to the deep of discussion. Right. Right. Because we know always if we apply F equal MA, we can apply Tn, we can take Tn Mg as forces. We are taking Tn Mg as forces. Right. If we take Tn Mg as forces, it's by convention we know these belong to M. But we don't know the actual reason, right? But we don't know actual reason why it is not, why it is on the string, right? Why we are marking a force on a mass, on a block, in a different thing. We don't do that, right? So what is the specialty here? Okay, so I will draw the things separately. This is the ceiling. Online students can't see it. This is the ceiling, right? This is the ceiling. And this is the string. This is the ceiling, this is the string, and this is the mass. N. Right? Listen carefully. This is very much important, and even I think 80% of the students don't know. Right. So think about like this. If you are placing a sheet of styrofoam instead of a ceiling block, right? අපි මේ ceiling කැටයක් ගලවලා piece of styrofoam දානවා. Styrofoam කියනවා ridge foam. හරි. නිකන් thin piece of ridge foam දානවා. අපි මෙතෙන්ට ලොකු weight එකක් දැම්මොත්, if we place a greater weight to this, what will happen? It will break down the styrofoam and just fall down, right? So why it will fall down? Because why it will break? It will break the styrofoam, right? So why it will break the styrofoam? What is the force acting on the ceiling? So it is the important thing. What is the force acting on the ceiling? To which direction? To downward direction. If it is a force to upward direction, it must go up, no? So if it is falling downwards, we have to remember this thing like this. This is very much logical, right? If it is falling like this, we can think, right? මම මෙතන ස්විච් ෆෝම් එකක් තියලා මෙතන මෑස් එකක් කෙල්ලපුවම බොග් ගාලා ඇදගෙන වැටෙනවා මේකත් ගලවගෙන. It will fall down instantly. You have to think like this. You have to see it here, visualize it, right? So there is a force by the string, right? String is giving the force. Can you understand? String is giving the force to the ceiling. So it is force by string on ceiling. Got it? Everyone got it. So let me introduce you this. So there is exactly the mass mg here. So in order to make this m mass at equilibrium, to stay this in equilibrium, what should be the force acting on this block? What should be the force? Is it upward or downward? Tell me. It must be a upward force. It must be a upward force, and I'll take this to be, think like this. So what is giving this force? Is it ceiling? No. Is it string? No. So then what is it? It is the string which is giving this tension. This force is given by the string, right? Get it right? So I will name this force as force on block by string. So if there is the force on the block by the string to upward direction, there must be the reaction pair. So this is the action reaction pair. So where is the reaction pair? If there is like this, the force like this to upward direction on the block, there is a reaction pair on the other object. So what is the other object? The bottom end, right? Bottom end is the other object. So what is the direction of force here? Downwards. I think I know. Now you are confusing things, right? Okay. Just keep that in your mind. This is the force on the block, and it is force on the block by the string. And the reaction pair is acting downwards because it must be opposite in directions. Force on string by block. So what is happening in this sum? There is a force to downward direction by the string. So what is the reaction pair? It must be a force in upward direction, force by ceiling on string. Understood? So what we mark like this? I taught you just now. And දැන් කියලා දුන්නා. This is the force on the string. So what the heck we mark on this like this? Like tension. I taught you earlier, if there are two blocks, tensions are like this, facing each other. I didn't give you a reason. Tensions are like this, facing each other. All right, okay. And also, I am saying now, the tensions are not the tensions, the forces lie like this. So what is marked as T? What is marked as T? Reaction force? No, not reaction. This is the force on the block by the string. And this is exactly force on the string by the block. And this is force on the ceiling by the string. Force by the string on the ceiling. And this is force by the ceiling on the string to the upward direction. The reaction pair, exact reaction pair. And this is also action reaction pair. So just keep that in your mind. This tension is marked as this force, right? We mark the force on the block. Instead, we cannot mark it like here. No? So we are marking that here. අපි මෙතන mark කරමු. අවුලක් තියනවද? නෑ, we can't mark it like here. Tension. No. So here we take tension to be the force on object by the string. Understood? We take tension to be the force on object. This is the force on object, the block. by the string. So what we consider as tensions? Force on the object by the strings. Is it force on the string by the block? No, you all get confused at this point. Why? You all are thinking, this is the tension is the force on the string. Is it? No, you have to keep this in your mind. Force on the string by the block, it is right here, right? So what we mark as tensions, it is just force on the block. That's why we can include this force T, this tension T in F equal MA when I apply F equal MA to this mass. Can we apply forces on other objects when we apply F equal MA? No. So we know this tension belong to this mass M. So we can include this tension while while using equations. Everyone got that? I need all of you to raise hands if you understood the point. This is a much important point, and more than 80% of physics students don't understand this. If you understand, I'm also in the right direction and you're also in the right direction. Right, good. Hmm? නෑ ඒක කැඩෙන්නේ ඉතින් ස්ටයිරෝෆෝම් එක හයි නැති නිසා. නෑ දැන් මේක ඇවිල්ලා මෙයාව අදිනවනේ කොහොමත් මෙතන weight එක නිසා. Right? This is the force on the ceiling. මේක අදිනවා. හිතන්න නිකන් දැන් මම මේක I will replace this block of ceiling by a styrofoam and held the mass like this. So will it break? Yes, exactly. Because there is a force on the ceiling to downward direction. So you can keep that in your mind like that, right? So in the papers, multiple times they are asking this question in different ways. If you don't know this theory, how to get this, you don't ever get this question right. So can you remember this? So what is tension? It is force on the block or the force on the object. That's why we include tension in our equations, right? මෙච්චර කාලේ equations apply කරාට දැනන් හිටියේ නෑනේ. හරි. අද දැනගත්තා. මොකද්ද? We consider tension to be force on the object, not on the string. What is the force on the string? The equal and opposite force to the other side, right? So there is a diagram given and you have to mark this thing. I will wait. Right. So you have to mark these forces in the diagram given and draw this, and draw this. There is space given in the tube. If you don't have tube, just put the page number 5, and draw this. And you need to take printouts and complete the text. Force on the string by block. Force on the string by block equal force on the C. Yes, because this equal to this, mg equal to this force, and action reaction this equal to this force, because these are in equilibrium, and this equal to this force, and finally this equal to this force. And we are when we are considering as a system, do we have to take these forces, these action reaction forces? No, we don't consider those things. When we need the tensions to apply equations, we just consider the force on the objects, right? So the tension is force on the object. If they ask about the force on the string, so it is exactly the opposite. Keep that in your mind. It is a major point in physics. If you have any questions, ask me. Right. Finish. Yes. Okay. Right. Okay. I think all good. Fine. So now we are going to move on to heavy strings. Heavy strings. So what I taught just now, what I taught just now, it's about light inextensible string. And these are heavy inextensible strings. Heavy means what? It have a specific mass, just like a rope. Right? එතකොට මොකද්ද මේකේ case එක? What is the situation here? Simple. වට්ටම simple. What is like this? Yes, this is a ceiling. පාලා දින්න ඕක ලියලා. හරි. And it is a rope with a mass. So it is a heavy rope, right? It is a heavy rope. So this is a mass. I'll take its mass as capital M. Right. So what are the forces acting here? It is the important one. What are the forces acting here? We know this thing. Is that its weight component, capital M G. So what are the other forces? Tension. Hmm? Tension එකට MG එකක් add වෙනවා. No. හරි. Just tell me where is the mass of, I mean, where is the weight of this string is acting? At the center of gravity, right? I think you know center of gravity for a small object, right? For this object, center of gravity lies here, right? For this object, center of gravity lies here, like this. For a rope or a string like this, center of gravity lies exactly here. If the rope is horizontal, if the rope is horizontal like this, the weight is acting like this. Okay, so here, here it is vertical. So where is the weight acting? It is acting from the exact middle, right? It is acting from the exact middle. And what is the weight? I'll take the mass of the rope to be simple m. So the weight is mg, right? Okay, so we know that thing, right? So there is an important question for you. So is this tension equal to this tension? What will happen? So give me a relation for tension this T, T dash. I'll take it as T dash. Just give me a solution for this T dash. I need your answers to be in the chat. Right, quick. I need a relationship for this T dash. Quick, quick. Not equal. Yes, not equal. I need a relationship. Just take some time and tell me the answer. Okay, so without going to that, I will come to that point later. Uh, we have to understand this, right? Like the same thing. If I draw, if I draw the ceiling, so what is this? Force on the ceiling by the string. Force on the ceiling by string. We know that, right? So if I draw, this is the this is the string. So what is the force on the? What is this force? Force on the string by the ceiling. Force on the string by ceiling. I need the answers from you for this question. Before that, I'm explaining this, right? And this, okay, I'll consider this one. And this is the weight. And this is capital Mg. And this is what? What is that force? Force on the block. It is acting on the block. Force on block by string. Force on the block by the string. And there is another force acting here. What is that? Force on the string? No, it is weight. Weight of the what? Weight of the rope. Weight of the rope. Mg. So these are the exactly all the forces acting on this setup, right? So you can draw these things. I think you can understand. What is the changing point? It is just this. And also this is also the same. Force on string by block. It is exactly the same. So what is the changing one? The weight of the rope. Write down this and think about a relationship why T dash is not equal to T, and how to take T dash. Right. If you have any questions, just tell me. Just post that into the admin chat. Always send questions to the admin chat. Otherwise, I won't see those. Right. Okay. So I need the answers. I will explain the little thing. And after that, T dash equal mg plus T. It's also correct in a way. And is the force on the ceiling by the string tension? Yes, the force on the ceiling by the string, it is what we called as tension. And also force on the block by the string, it is what we called as tension. Good. Yes, that is. Mm, using Newton's first law, T dash equal mg plus capital Mg, T dash equal. Yes, good. Keep up. You're good. Right. So I will explain this like this. I will erase. हाँ बंदा explain कराने हैं. Right. Think about a situation like this. There is a, there is a string hanging like this, just a string. Right. There is no object to support, just a string. So what are the forces acting here? Yes, a heavy string. Mg, simple Mg. Tension, yes, tension to this. Right. I'll mark it as T dash. So what is the tension here? Tension at the low value, Mg. Ah, is there anything to support? No, there is no anything to support. And also, is there any mass of the string furthermore? No, it does not need to support any strings, right? It does not support the string mass, right? This is the ending point. So, at the ending point, what is the tension? It is equal to 0. Got it? Right? Okay. If there is a mass mg, if there is a block, so what is the tension here? It must be capital M G. Then there. Right. Capital M G. So what is the tension T dash? T dash must support what? This capital Mg and this simple G. So T dash must be equal to capital Mg plus simple Mg. So it is equal to M plus Mg. And also one gave answer T dash equal to T plus Mg. Is it correct? Yes, it is also correct because this T is equal to capital Mg. Obviously, you will get this, right? Okay, so it is also okay. I'm asking, I need the answers for this. I'm asking, what is the tension at the middle point? So if you are marking tension at a point in a row, you mark it like this. This is the tension component belong to this section, right? This is the tension component belong to this section. Understood? So what is? Think like this. This is a string, heavy string, and it is attached by a light string, and this is the other heavy string. So what is happening? This is the, so what is the force on this heavy string by the light string? Force on this by the light string in the upward direction neither. So what is the force on this by the light string? It is in the downward direction. I explained you earlier these things, so now you can understand. So this is in the downward direction. So what is happening? These are the tension components. Always, what is tension? Force on the object. Force on the object. Keep that in your mind. So this is the tension components. So I will take it as T naught. and this is also T naught, right? So I need answer for T naught. What is T naught? Tell me. You don't need to type T naught. Just type the expression. Right. Be quick. I need the answers. Right. Give me the answers. Post it in the everyone chat so I can see. It is very difficult if you send these answers in private. So yes, වැරදුනාට කමක් නැහැ. එවන්න. මොකද වැරදුනොත් තමයි කවදා හරි හරියන්නේ. නැත්නම් ඉතින් හරියන්නේ නැහැ නේ කවදාවත්. Just send the answers. There are no wrong answers here. This is just phase. No sign phase. Phase and you have to send the answers. You have to think what is happening. There's a signal lag. Right, okay. So just post the answer. What do you think? I need 14 answers from, not 14, 13 answers. No, 12 answers. Right. Okay. I need 12 answers. So what is the tension here? T naught. And they are also, so what is the tension here? T naught. Quick, quick. This is how you have to learn. You have to test out the things. So what do you think? Capital MG. Of MG. Yeah. No idea. MG plus MG. Right. Okay. So what are they saying? P dash minus MG over 2. Yes. So what is happening? Just think it like this. So what are the forces? I mean, just think like this. If we divide this string into two like this, so what are the weight components? So this is the weight mg over 2, and this is the weight mg over 2, acting on two bodies. Think like acting on two bodies, right? In the same string also, if they are asking you to find the tension at the middle point, divide this into two parts and think it like this. So this is mg over 2 in the midpoint of the specific section, and also this is mg over 2 in the midpoint of the specific section. So there is a force, not mg. We can neglect this, and mg over 2 acting downwards. So what is the force that is needed to be balanced by T naught? T naught should balance what? This capital MG. Okay, this capital MG obviously is balancing, and also what? This MG over 2. Although you write T naught equal T plus mg over 2, it is also correct because why? This statement holds true, right? This is a true statement for any scenario. So if we take it like this, what is the force acting here? So what's going to happen? It is, here it is 3/4 of the length. Tell me. Now you have to give me answers. There also you can divide like this. This is the, I take this to be T2. Yes, I need answers. What is T2? Answer mg plus. So online students sleep in the I need answers. The more you answer the questions, you will learn things, right? Without answering or without thinking, you will not learn anything, right? So T2 must balance what? This whole weight. T2 must balance this whole weight. So this whole weight is 3 over 4 simple mg, and also obviously it has to balance this capital mg also, right? Mhm. Got a point. T plus 304 mg. Right, good. So this is the tension T2. So we can arrive at a conclusion and the equation. What? If we need to find the tension at x distance from this, if we need to find the tension at x distance from this, the tension T naught, I will write it. T naught equal to what? Mg, it is yes. Mg, yes, plus what? X over L. Like here, 3 over 4. Ah, if the length of this is 10 meters and they are asking 9 over 10, right? If this distance is 9 meters and whole distance is 10 meters, the length is 10. So what should be right? 9 over 10, simple M. So you can find out any tension at any point of a heavy string using this equation. Yes, good. So yes, you can write down. This is like heaven. Actually, do. You have to write this, and the general equation this. If you write just the general equation, you will not remember anything. කොහේ ලියාගනින්න ඕක දැන් මේක ඕන වෙනවා කොහොම හරි. හරිද? මේක කොහොමත් ලියාගන්න. If you have space, write down this and this also. Right? පොතේ හරි ලියාගන්න කමන්නේ. Isn't there any space in the tube? No, right? So write down this in the book. This is much important. That's why I'm asking you to find. Right. No, we can't write as x into mg here because we wrote this to be 3 over 4. 4 means the total, the fraction. I mean, we have to write it as a fraction of whole thing. 3 over 4 mg. Like that, this is 1 over 2 mg, and also it is also x over L, right? It is a fraction of the whole length. ඉක්මන් කරන්න මේවට ලොකු වෙලාවක් දෙන්න බෑ අපිට ලොකු වැඩ ගොඩක් තියෙනවා කරන්න. නන්දයක් විතරද? හරි මම දැන් මේ කියපු ඒවා ටික දැක්කනේ අඩුව තරම දැක්කනේ හරි කවන්න එතකොට what has happened 70% of students who sat in A levels got either F or S ටෙන්ෂන් කියන්නේ මෙහෙම දැන් ඒ කියන්නේ A levels වලට යද්දි මම මේගොල්ලන්ට මම කතාව කිව්වා A levels වලට යද්දි ඔය strings වල මම දැන් ටෙන්ෂන් කතා ටිකක් කියලා දුන්නනේ force on the string by the ceiling ඔය අනම්මනම් maths අනම්මනම් කිව්වනේ දැන් ඔය ඔළුවේ තියනවනේ උඹලගේ ඔය මුකුත් මම දන්නේ නැහැ එළින් කියලා දුන්නේ නැහැ බං ඉතින් කියලා දෙන්නේ නැතුව කොහොමද දැනගන්නේ ෆිසික්ස් වලට B එකක්ද තියෙන්නේ කියලා අහන්න එපා බං හරි අර මගේ ටියුට් වල තියෙනවා යටි හරි ඒක කියවපන් එතකොට B එකක් කරන් යන්න හරි එතකොට මේ මේවා දැනගෙන ගිහිල්ලා ඒකක් ගන්න පුළුවන්ද පුළුවන් අනිත් ඒ ඔක්කොම හරියටම දන්නවා හරිද ඒක නිසා ඇත්තටම අර දැන් ඉතින් අද මේ දවස්වල ටියුෂන් කියලා කරන්නේ එනවා ටියුට් එක දෙනවා ළමයි 3000ක් මැද්ද ගිහිල්ලා ඉගෙන ගන්නවා ඉතින් මේ 170 ඕම ෆේල් වෙනවා මෙතනින් 105ක් අය ඒකක් ගන්න ඕකනේ ඉතින් කතාවනේ උඹලා ඔය සෙක්ෂන් එකට යන්න ඕනේ නැහැ ඉතින් මෙච්චර උගන්නන්න ඕනෙත් නැහැ ඔය සෙක්ෂන් එකට යන්න 170ට 70ට නේ මන්නම් කියන්නේ මේ 190ටම යන්න ඕනේ නැහැ මොකටද මේ ඉතින් ඒ SFC අරගෙන මොනා කරන්නද ඕනේ නැහැ ඉතින් AB එකක් ගන්න පුළුවන් අනිවාර්යෙන් මේ විදිහට සිලබස් එක ඉගෙන ගනින්න දැන් නිව්ටන් මේ වෙනකන් කියපු බයිලා ටික තේරුණානේ තේරුණා නම් බං මේ විදිහට ඉගෙන ගනින්න මේ විදිහට උගන්වන එකෙක් ගාවට ඵලයල්ලව මං ගාවට එන්න එපා මට වෙන ඔය ඉන්ඩිවිජුවල් එකක් මුකුත් කරන්න මට වෙලාවක් නැහැ හරිද ඒකින්ද මං ගාවට එන්නත් එපා අහන්නත් එපා හැබැයි මොකද්ද හරියට උගන්වන එකෙක් ගාවට පන්ති බලයන් බං නිකන් බොරුවට අර මේ හෝල් ක්ලාස් කියලා යනවා ළමයි 3000යි 4000යි සර්වර් පේන්නෙත් නැහැ අර ස්ක්‍රීන් වලින් සර්වර් පේන්නේ අමු බොරුවනේ කරන්නේ ඔය හෝල් ක්ලාස් වල යනුන්ගෙන් 90ක් විතර මේ ගොඩේ ඉන්නවා 90ක් විතරම ස්ටෙප් ගන්නෙ නිකන් බොරුවට ඇයි කියපන්කො දැන් අපිට කියනවා බොරුවට මොනවද මේ පාර A 2000ක් තියෙනවා ඌ උගන්වලා තියෙනවා ළමයි 25000කට විතර වැඩක් තියෙනවද කියපන්කො නෑ ඉතින් වැඩක් නෑ A 2000ක් තිබ්බට වැඩක් නෑ මේක මේ පට්ට අඩු පර්සන්ටේජ් දැල්ලුවා දැන් මේ පාර මම දැක්ක දැන් ඔය මම අඳුරන සර් කෙනෙක් කෙමිස්ට්‍රි උගන්වන සර් මුළු ක්ලාස් එකෙම 140 ගාණක් ඒ අන්න බෑ පට්ට බෑ 144ක් විතර 43ක් 44ක් දී සුපිරි ඒක තමයි වෙන්න ඕන මේක මේ මෙච්චරක් තියෙනවා අයිලම් ෆස්ට් වෙච්චරක් තියෙනවා ඒක මහ බොරු ගොන් ගුරු කතා අයිලම් ෆස්ට් කෙනෙක්ව හදන්න බෑ බං ගුරුවරයෙක්ට ඌ කියන්නේ වෙනම මීටරයක් අපි ඉතින් අපේ කැම්පස් එකේ ඇතුළේනේ උන් ඉන්නේ ඉතින් අපි දකිනවා ඌ උදේහවා උන් කියන්නේ බං උන් කියන්නේ මේ පාරේ යද්දිත් ඌ ගණන් හදාද යන්නේ එහෙම ඩයලොග් ඉන්නේ අයිලම් ෆස්ට් දිස්ත්‍රික්ට් ෆස්ට්ලා උන්ව හදන්න බෑ මේ ඔය ටියුෂන් බූරුවන්ගේ කතා ඒකින්ද මේ ඒ වලට අහුවෙන්න එපා බං අන්තිමේට දැන් උඹලා ඒකක් ගත්තොත් උඹේ ෆොටෝ එක දාගන්න උඹේ පැත්තෙන් එනවා මේ ඒකක් ගත්තොත් මටත් ඒවම ෆොටෝ එක පුළුවන් එතකොට මේ එහෙම නෑරෙන්න ෆේල් වුණාට පස්සේ කවුරුත් එන්නේ නැහැ බල්ලෙක්ව බලන්නේ ෆේල් වෙච්ච උන්ගේ ෆොටෝ ලිස්ට් එකක් දානවද නම් ලිස්ට් එකක් දානවද ඒකින්ද පොඩ්ඩ ඔළුවෙන් වැඩ කරහල්ලා නිකන් බොරුවට අර ටියුෂන් උගන්වන උන් ගොන්නු තමයි ඉතින් මම කියලා මේ උන් පස්සේ යන්න එපා මාක් කරන්න ටියුෂන් නෑ එහෙම නෙමෙයි මල්ලි ඒ කියන්නේ ඔව් මල්ලි නම් කිව්වට කමක් නැහැ නේ පොඩි උන් නෙමෙයි හරි මේ ඕක තමයි ඉතින් කතාව ටියුෂන් ඇතුලේ තියෙන තනිකර අවුන්තුම සීන් එකක් දැන් දැක්කනේ අර අයිලම් ෆස්ට් මරා ගන්නවා දෙන්නේ දුන් දෙන්නේ දෙක දෙක පිස්සුනේ බං මන්ද මානසික වගේ නේ බං පොඩි උන් වගේ නේ අර ඕක මගේ මේක මගේ ඊ අර මරා ගන්නේ වර දෙපැත්තට දැයි ඊයව නෙත්තකි හරි so we are moving to an important section right this is very much important always this is a important section when we are talking about friction friction is a important section in order to go to that we need this part this is normal reaction කියපු ගමන් හිතන්නදී අයියෝ මේක දන්නවනේ we have to learn normal reactions very carefully because in the definition normal reaction of an object is the exact force given to the object by the surface perpendicular to the surface so this is much important perpendicular to surface is it perpendicular to object no always it is the force given by the surface to the object perpendicular to the object turn to page number 9 there is normal reaction topic The normal reaction is the perpendicular force exerted by the surface on an object in contact with it. We know all that. Its direction is always 90 degree to the contact surface. It is always perpendicular to the contact surface. So what will happen? So if we draw a block like this is the flow. So what is happening? This is the weight, mg. And due to this weight, it creates a mg on the floor, right? If this is a table, it is creating a mg component on the table. And if we hit something, it creates a reaction for us, right? If we hit a ball, there is a reaction opposite to us on the hand, right? So what is the reaction? I will mark this force in blue, not in blue, in black. It is the force on the table. I discussed this earlier also. So to cancel out this as a reaction pair, there is the normal reaction. And we can write normal reaction is equal to mg in this situation. These two are not action reaction pairs, but this and these are action reaction pairs. Got it? Right. If you are marking forces on the object, do we want to mark this one? No, it is on the table. We don't know this. Just these two. And these two are not action reaction. Okay, so right, that is also fine. If the wall is like this, what is happening now? And the block is here. What are the forces on the block? There is a weight mg and the reaction due to weight, I take it as R. And also there is a reaction by the wall, right? There is a reaction by the wall, I take it as S. Can you understand this situation? I think you know this. Okay, this is the forces acting on a block which is covered by two walls, right? If you don't know this, just draw it, right? I don't give time. Right, the next thing, very important thing, there is a message. Mic is muted, right? Now it is okay. Right, so a reaction will act because it is forced towards that direction, because the block is forced towards that direction, right? No, no, right. It is okay. We will come to problems and it is much easier, right? The important thing is an inclined plane, right? Important thing about reactions is an inclined plane. I'll take it, not 30, I'll take it theta degrees to the horizontal, right? Theta degrees to the horizontal, and there's a block placed on the right here, right? So think it like this is a rough. This is rough. Okay. So what are the forces acting? There must be the weight. So what is the direction of weight? Always it is in the downward direction. Is weight is acting inclined? No, weight is downward. The gravitational acceleration is in downward direction. So the weight must lie in the downward place. So weight is from the center of gravity. We are discussing those things in center of gravity. But you know center of gravity is right here. So weight is acting exactly downwards. I'll name it as mg. Right? This is the first force on the block. So there is another force. What? Reaction. So reaction must lie perpendicular to what? Surface. Surface is this. and reaction must be this. Got it? Right. It is perpendicular to the surface. It is perpendicular to the surface, but I don't draw these things because you will think reaction is on the plane. It is not on the plane, it is on the object. So there's another thing active. What? Friction, because this is a rough plane. Can an object stay in equilibrium like this on a smooth plane? No, because I'll come to that point, but there is friction. This is trying to move on to this direction. So where is the friction direction? It is exactly opposite. Frictional force is acting exactly opposite in direction, right? You all know that. Okay, be quick. So what is this component of weight? mg cos mg sin theta. I'll tell you the derivation, but you have to remember this, right? You don't have plenty of time to solve these things and do simplifications, right? So you have to remember these things because they are fundamentals of physics, right? These are fundamentals of physics, so you have to remember these things and keep that in your mind. The component along the plane is always mg, the sine component, but the angle must be to the horizontal. If it is given to the vertical, it is changing. This will be cos. So in most of the calculations, it is theta is given respect to the horizontal axis. So it is mg sine theta, and this component we take it mg cos theta. I have divided this weight into two components. So do we need this weight furthermore for calculations? No, but it is a force acting on the block, and we have divided this weight into two components, right? Into two components, and this is the resultant. Why we divided into two components? Because we are applying equations in this direction or in this direction, right? We are applying equations in, I'll take it like this because it try to move into this direction. So we are trying to apply equations in along the plane and perpendicular to the plane. So what is the use of this? This is we cannot apply this into these equations, right? So we have to take components. So this this is the resultant, and we don't need to consider this because this will give the resultant of this, right? Okay, so I think you can understand now. And what is R? R is equal to what? Mg cos theta. But why? R equal to mg cos theta. But why? Because this cannot sink or jump, right? මේක උඩ පයින්නවද? නෑ. මේක ගිලාගෙන බහිනවද? No, this doesn't sink or jump from the plane. So R must be equal to this component, right? R must be equal to this component. So this is the first equation, and this doesn't move along the slope. So this is friction. I take it as Fr, friction, and it doesn't move along the plane. If it doesn't move along the plane, what is the equation we can write? Fr equal to what? Mg sine theta. This is the second equation. And we can solve problems using different approaches. We will do that in problem solving. Up to now, is it clear? It is clear. Right. So you have to mark this on the diagram given in the tube. There's a special point given. Right. We need to discuss that. Don't write. I need to discuss the special thing. If this theta increases at a point, this will slope, right? At a point, this is slope down. What will happen when theta is increased? When theta increases, What will happen to cos theta? Cos theta. What will happen to cos theta? You need to know this thing. If theta is increasing, this is theory. If theta is increasing, cos theta decreasing, sin theta increasing, tan theta increasing, right? Only cos theta is decreasing when theta is increasing. So I will increase theta. What will happen? Cos theta will decrease. Normal reaction decrease. So what will happen? This term increase. Weight term increase. FR friction means what? I haven't taught that yet. But friction is what? Mu times normal reaction. Ne? When normal reaction decrease, will this force be sufficient to handle this one? Because this is continuously increasing. Sine component is increasing when theta is increasing. This is increasing. This is a much higher weight, but this is a much higher force. But friction is decreasing. This is increasing. Friction is decreasing. So this slide alone display. Understood? If you have any questions, ask me. Right? I think you can understand now. If this is decreasing, this is increasing. Obviously, what will happen? The block will slide down with an what? Acceleration. Right. So you need to highlight even that important point if you don't know. Right. So mark the forces acting on the slide plane, not the inclined plane, and then there is scenario 3, objects on each other. So I need you to mark the forces on objects in the two diagrams given in page number 10. Right? Mark them. If you don't know this, write it down. This is an important thing. මේ කියලා දෙන විදිහට නම් බූරුවෙක් මෙතන ඉඳන් හිටියත් උටත් තේරෙනවා. මේකින්ද මේ පට්ටටම තේරුම් අරගෙන ඔළුවට දාගන්න. There is a question how to get cos and sine. Okay, I will explain. I missed that part. Don't we need to get the resultant reaction force? In the early example means, isn't it this one? This one now? Is it this one? No. So I think you are talking about this. This is object, and it is one reaction. It is another word. This reaction R, this reaction S, isn't it? Yes, if you want, but we don't want. If they ask what is the reaction, you need to take the resultant of R and S. What is the resultant of R and S? In this one here. What is the resultant of R and S? It is going like now, right? It is going, I will write it as resultant. Resultant equal root R square plus S square. But for the sake of applying equations, is resultant required? No. Applying equations, we apply equations in horizontal and vertical planes. Then no resultant is required, but they are obviously asking about resultant. Then you have to take this, right? I will forces in figure mg, friction, and R must meet at a common point. Yes. Yes, you are correct. I will talk about that in equilibrium, but for now, yes, you are correct. If an object is in rest under three non-parallel forces, the forces must intersect at a common point. The line of action of forces must intersect. And if you don't know that, just be okay because I will be teaching those things. Yes. Bad. Right. I think you wrote this thing, and I need to tell you how I obtained the angles. Right. So according to her, the reaction must pass through this. But for the understanding, I draw it like this from the middle. But uh, others don't think about that. I will explain everything within that lesson, right? I will explain everything within that lesson. For now, the the place of acting reaction is not much important, but the direction is pretty much important, right? So one is asking how I obtain this mg cos theta and sin theta. So how? This is theta. So this is what? 90 minus theta. So what is this angle? I think you can clearly see this. Yes, you can see. What is this angle? 90 minus theta. Why? This is vertically opposite angles, right? This angle equal to this angle. This is also 90 minus theta. So what is this angle? Theta, right? If this is 90 minus theta, this is theta. So this angle is theta. So what are we doing? Mg to this direction component to the side of theta, it is mg cos theta. And to the other side, mg sine theta. It is like this. The triangle is like here, here, and here. It is like this and this. This I took it as 90 minus theta because this is theta. This is 90. This is 90 minus theta. This is also 90 minus theta. This is 90. So this must be theta. And here only the mg is going. So mg cos theta to this side and to the other side mg sin theta. හරිනේ වැඩේ පැහැදිලි වෙන්න ඕනේ. Ask questions. If you have any question, ask. මෙතනින්ද? ඕක මම පස්සෙම කියලා දෙන්න එක්කෝ. It is because if an object is under equilibrium under three non-parallel forces, is these forces parallel? R, mg, and friction. Are they parallel? No. If they are in equilibrium under three non-parallel forces, obviously those line of action of those forces, do you know what line of action is? Yes, line of action of those forces must intersect at a common point. And it is a law of equilibrium. For now, that is okay, that is fine. I will talk about that in detail in next lesson. Right, I'll erase. Okay, ne? This is the today only we are doing a YouTube live. Otherwise, we are not sending YouTube lives. I mean, in tomorrow and day after tomorrow. Only the Zoom link. And the recordings will be provided such that they cannot be shared or something like that. But yes, it is. Recordings will be shared. You can read that only one time. And I'm doing that because I have asked several times in the group, if you have any financial problems, just tell me. There are some students who told me about their conditions, and these students are also okay, right? I will not teach on money, but we need money, right? So we need money, but I will not teach on money because education must be a free thing. Anyone must learn. Anyone must learn, but he or she has to inform. That is the like formal thing, right? Copying and stealing thing is not formal. Right. So shall I give a small interval because these people are having some problems? I will give a small interval, just 10 minutes, right? This is not lunch break. I will reduce this amount of time from the lunch break. If you take more time, I will reduce the amount from lunch break, right? So I will give 15 minutes, right? It is 12, 12:40. So we will come back at not 12:40, 11:40. So we will come back at 11:55. Right, 15 minutes. So sharp 11:55, you have to be here. Right. Right. So shall we start? Everyone there. So right. I asked you to mark forces in bottom diagram. So I'll draw the first one. It's like this. The second one, it is like this. Right. Okay. So I'll draw the forces on two diagrams with two colors, right? So the first one. Here, let me take the mass of this one as simple M and this one as capital M, right? So weight of this one. What is the weight? M G, right? Simple M G. And this is strictly influencing, which is strictly influencing the bottom side of this, right? I mean, this is giving a force on this one. Do you remember that thing? Right? There was a block on the table, and this mass mg creates a force on this object, right? Because of that, it gave a reaction R, and also, and this is equal to mg, this is equal to mg, and because of this object gives a reaction to this object called R. And what is the magnitude of that? It is also equal to mg. Now you can do that, right? So this thing, Michael, no, this is not capital Mg. Why? The weight of this one is simple Mg, and it is acted on this block, and equal and opposite reaction is acted on the other block, R equal simple Mg. Understood? Right. There is inbuilt force. What is that? The weight. Inbuilt force, capital Mg. So what is the reaction that must act? I mean, I will take this as the flow. What is the reaction must act on the body by the flow? What will be the reaction? I will take the reaction to be this one, and I'll take it to be R2. This is R1. What is R2? I need answers for this block. What is R2? So, chat, post your answers to the chat. What is equal to R2? Coco. Hmm. 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 Someone not responding, I don't think you are learning or not. Right. So what must happen? In order to make this block, consider forces only on this block. So in order to make this block at rest, what must we do? So this must be in equilibrium, right? This is in equilibrium. So upward forces must balance with downward forces. So mg plus capital Mg is balanced by what? R2. It is simple, right? So what is happening? This is Mg, simple Mg. It creates a force on this block, simple Mg. And due to that, it gives a reaction on this block, simple Mg. It is okay, right? Then there is an inbuilt force. What is that? Capital Mg. It is inbuilt to the block. So Mg plus simple Mg, it must be balanced by capital R2. Otherwise, what will happen? The block will fly, or it will sink, right? So block will fly or it will sink if R2 is greater or less than this thing. So I think it is clear. So the next one, Right. Right. Is this there are blocks A and B. Right. This is A block. This is B. This is A. Right. Yes. So what are the forces acting here? They are given to be smooth, right? Consider them to be smooth. So tension first. So is the tension same in both situations? Yes, because that is the same string. So T and T. I will mark forces on that object in blue, right? So this force, this tension is capital T. They are equal, right? So what is the direction of weight? What is the direction of weight of A and or B? I mean, direction of A or B. What is the direction? It is exactly downwards, right? The gravity is acting downwards, so the weight must lie downward direction. So this is, I'll take mass of this one to be simple M, this one to be capital M, right? So this is mg, and also this weight, what is this? Capital Mg, right? Fine. What are the other forces? The normal reaction forces, right? Here it is R1 acting on this block by this block. Normal reaction is a force acted upon the block acted upon an object by the surface perpendicular to the surface. This is a surface and this is the object. Relative to this situation, this is the surface, this is the object. So this surface exerts a force perpendicular to that object, that surface, and it is R1, right? So what is the reaction exerted on this? Is there a reaction between this and this? Flow and this? Yes, there must be. So I mark this reaction. It is should be marked in blue. R1, and on this there must be a reaction R2, right? All of them must be perpendicular to the surface. And if you ask me what are the values of R1 and R2, you have to simplify this, right? You have to simplify by taking components of weights, right? It will be solved in questions, but up to now, can you understand how to mark forces, right? Right. Okay. So we are moving to some problems. This. එකම line R1 plus R2 where this force acting on this block and this force acting on this block, right? What is happening here? This R2 is equal to R1 plus why R1? If this gives a reaction R1, there is opposite force on this block, right? We have to mark that also. R1 on this to the downward direction, right? So there is a force R1 to the downward direction. It is a force, so you have to mark that. And so what will be R2? R1 plus what is the component of this? Mg cos theta. R1 කියන්නේ simple mg cos theta, right? A weight the component of that weight is R1, right? It is acting on this block, and if it is acting on this block, it gives a reaction like this. This mg is acting on this box. So if this mg is acted upon this block, it gives an equal and opposite reaction. What is happening here? Here, the mg component of mg acting here, R1, right? Because of that, it gives a reaction R1. What is that R1 value? It will be mg sine away cos, cos, to this direction it is cos, so mg cos theta. And then R2 means There is R1 to this direction, right? And also component of its own weight. It is capital Mg cos theta to this direction. So R2 equal R1 plus Mg cos theta. Got it? I'm on there now. Right. Online students, hands up if you understand this. Hands up if you understand what I taught you just now. What about Bihangi and Sandrine Fernando? What is your question? Just post that. You're okay. So what is about Sandrine Fernando? Do you have any questions? How to get that cost? How to get that cost? Cost come from what? Do you remember this thing? In an inclined plane, weight is this. Weight is acting downward. So what is this component? I told you earlier, this is mg sine theta. And this component is mg cos theta. And there is normal reaction. In order to balance, this mg cos theta is equal to the normal reaction, right? So what is giving like this? So mg gives a force R1 to this direction, the component, right? This R1 is always equal to what? Simple mg cos theta. Understood? So how I got this one? Simple mg cos theta is in this direction. This is the force applied on the bottom block, like this one. This is mg because it is in the not in an inclined plane. This is in an inclined plane. So this is the component. R1 is equal to simple mg cos theta. R1 equal to simple mg cos theta. And R2 is equal to R1. There is a force like this in the downward sense. And R2 equal to this cos theta plus this R1. He has to balance that. So R2 equal to this. Can you get that? Now is it okay? Yes, good. Right. You need to do question number 1 in page number 14. Question number 1. Question number 6. You have to do question number 1. Question number 6. And yes. And question number 10. Now you can do all of this. Question number 11. Question number 12. No, that is okay. I will explain after 2 questions, right? 2 by 2. We'll do 2 by 2. So do question number 1 and 6 and just send done to the chat, right? Or raise the hand. Do first 2 questions and raise the hand. If you completed, please raise your hand. First two questions. If you completed first two questions, raise your hand so I can discuss, and you can do 10 and 11 after that. Mhm. Until others are finishing question number 1 and 6, you can continue to question number 10 and 11. Don't just sit. Hmm? Yes. Hmm. Question number 10 එකේ arrow එකේ තමයි base එකක් තියෙන්නේ. මම මේක check කරන්න. Namang එකේ. මොන හරි කියලා තියෙනවා. Down the plane කියලා තියෙනවා. Yes. So we will discuss so in 11 tensions acting on two masses are different. 11 so two masses. Think about that. What I taught you earlier. Sin 20, I don't know. You have to find out that it's logarithmic, that not sine tables, right? So sine 20 value is 0.342. Sine 20 equals 0.342. So there's a question in 11, tensions acting on two masses are different. So think about what I just taught you. In a light inextensible string, if it is just one string, if it is a single string, always everywhere tensions are the same. If it is a single string, right? Think about right. So I will discuss question number 1, right? Please listen to this. Right. This is the diagram. So what will happen now? I'm going to mark the forces. Listen. So if I apply a force here, it will apply a force here. It will be a reaction force. I'll take it as R1. Why? If I keep a smaller block on a large block, the weight will apply here, mg, and because of that, and reaction is formed. Like that, due to this force, the reaction is on this block, and in the opposite sense, there is a reaction on this block, and the same reaction R1, right? So due to this R1 pushing this side, there is a reaction R2 on this block. There's a reaction R2 on this block. I will do it with black color. R2. So opposing that, due to that, there is a reaction formed as action reaction pair to this as R2, right? And again, there is a reaction formed due to this R2 as R3 in this, and due to that, there is a force R3, reaction force. And again, this forms a reaction on the it is a trolley, right? Or a toy car, right? On the toy car, which is R4, and an equal force is formed on the block, which is R4. This is the horizontal force analysis. I will not draw vertical forces here because it will be too much messy. So yes, we will do the question. Calculate the common acceleration. The common acceleration when we want to take the common acceleration, do we want to consider these action reaction pairs? No, we can apply F equal ma to the whole system. When we apply F equal ma to the whole system, these action reaction pairs cancel out. R1, R1 cancel out, R2, R2 cancel out, R3, R3 cancel out, R4, R4 cancel out. The only force remaining is this F. So what we need to do? Apply F equal ma to system. So we're going to apply F equal ma system. So the total force is F, which is what? How many newtons? 140 newtons, right? Yes, 140. 140 equal total mass. 4 plus 4, 8, 10, 12, 12 plus the trolley mass, it is 14 times acceleration, A equal 10 ms minus 2. So, raise your hands. Still there are someone raising their hands, but raise their hand, you got this answer. Only if you got this answer. Is it correct? Good. What about Kujani? Is it fine? Also, okay. Okay. Then the next one, and mutual reaction forces between the blocks. So how do we find that? We have to apply, this is a common acceleration A. This is common acceleration A. So we need to apply our F equal ma equation individually to each block. So in order to apply that, you need to have a sound knowledge how the reactions are formed. If you have any doubt regarding how the reactions are formed, just let me know, right? Just let me know if you have any problem regarding marking reactions. So I will apply F equal ma to block A, right? This is block A, this is B, this is C, this is D. So block A to this direction, this is also to this direction, right? The only forces are yes, there is acting F to this direction and R1 to this direction. So F is 140 minus R1 equal to mass is 4. 4 times acceleration, it is a common acceleration. So it is 10. So R1 equal to 140 minus 40, it is 100 newtons. Is it correct? Right. Next, F equal ma to B to this direction. I'll write fast. R2 minus R1 equal 4 times 10. R2 means it is what you need to find. Minus 100 equal 40. 140 Newton equal R2. So again, we will apply F equal ma. Again, we will apply F equal ma to C to this direction. On C, R3, no, R2 is acting on that direction minus R3. Yes, equal to mass is 2 times acceleration is 10. So R2 we know 140 minus R3 equal 20. R3 is equal to 120 newtons. So we need to find R4. Just apply again F equal limit to this direction, and R4 equal to mass is 2 times 10. R4 is equal to 120 newton. Is it correct? Are they correct? R1, R2, R3, R4? No. Mhm. Are they any errors? Isn't R2 60 newton? So what happened? Ah, Hari. That is it. We are applying equation to this direction. So I have to take R1 positive. I have changed those two. So the whole sum will be incorrect after that. So, okay, good. R1 this side, R2 this side. Yes, R2 60. R2 60 means 40. Then right, these are the answers. Is it correct? Those who got all these things correct, raise your hand. All question correct. Good. Others try to catch up things. Oh, there are means. Okay, good. Rough. Maker of man. Oh, servicer of man. Yes, what are you talking about? ඒක ඒ කියන්නේ process අරගෙන apply කරලා finally you have to find result. යන්න අමාරුද? ඒ කියන්නේ consultant එකේ මේ දෙන්නටම apply කරන්න දෙන්නේ නෑ. 1.5 කට in this direction component එක තියෙනවා ඒ direction එකේ තියෙන එච්චරයි. මේක weight component එක and මෙහෙට tension ඔච්චරයි තියෙන process. මේකට තියෙන tension එක විතරයි. අනේ මෙයටත් තියෙනවා. No. Let's do question number 6. I'll erase. Right. So in the sixth question, uh, I don't need to. Um, yes, I'll just mark the forces. The weight, 40 newtons. The weight again, 60 Newton. I think you read the question, so I don't need to read the question again. So it is R, it is R2, R1. And tension T, tension T. Right. The components 40 sine 30, 40 cos 30. It is 60 cos 30. It is 60 sine 30. Right. So what shall I do now? I will apply F equal ma to whole system. They're asking for acceleration. Yes. To whole system, I will apply F equal ma system. I need a direction. I will select this direction because it is trying to move in inclined plane. So 30. Right. So what is the just force acting in this direction? It is F. We don't mind these tension values because when we think about the system, the whole system, when you think about the whole system, these forces get cancelled out. So 50 minus, there are components of weight. 60 sine 30, 40 sine 30. Sine 30 means half. So we can directly write 20 minus 16 divided by 2, 30 equal to acceleration is becoming zero, right? Good question. Equal to ma. We don't need to even try to write the mass because mass is 10. Combined mass 10 times 8. Although it is 0 ms minus 1. So it is moving with what? Constant velocity. Or it can be at rest also, right? Newton's first law. So tension. Tension name what then? No. What must be the tension? You don't need to solve. If it is 50, it must balance with tension. So tension will be 50 newtons because this is not an accelerating diagram. It is a hmm? Yes. Hmm. Good point. So Yes. So what we need to do? I thought about the equilibrium of this block. This block has a weight itself. So I can't say 50 is equal to T. There is error. So we have to see upward forces equal to downward forces. So upward force is 50. It must balance with tension plus this 60 sine 30. Tension plus 60 sine 30. This is 30. And tension is equal to 20 newtons. Press. මෙයාට 40 sine 30 equal to T කියලා ගන්නත් පුළුවන්. You can also take 40 sine 30 is equal to T because there is no F component. No. Then 40 sine 30 is 20, right? With the same answer. Those who got all the answers correct, raise your hand. Good. Yes. Okay. Sir got wrong, but student did it correct. Yes. Good. So you need to do question number 10 and 11. Always think if it is a light inextensible string and it is just a single string, always tensions are equal. we'll do question number 10, right? So how to do question number 10? Just mark the forces. How we mark the forces? Tension T, tension T. And then weight here, this mg, and this weight here, 1.5 into 10, 15 Newton. And now there are reaction forces. How the reaction forces are formed? I will not mark because the friction is not involved. How reaction forces are formed? Here, mg is in this direction. So mg cos theta component creates a reaction here, right? This is equal to mg cos theta. And due to that, a reaction force is created here. You done either. You can understand those things. And also, there's weight capital mg here. So there is the component capital mg cos theta. So this reaction must be simple mg cos theta plus capital mg cos theta. Right. I don't mark those forces here because I will apply only F equal ma to along the plane. I will not apply perpendicular to the plane. So I will not write those equations. So I will apply F equal ma to 1.5 kg mass downwards. It is said in the question, the masses in the given apparatus begin to move freely from rest without any friction. The acceleration of 1.5 mass is down the plane 1.2 ms minus 2. So 1.2 ms minus 2 down the plane, and this has a acceleration 1.2 ms minus 2 up along the plane. It must, right? If it is downward, this is moving upwards, right? So how do you apply F equal ma to 1.5 downwards? So you need to take components of weights. What is the alone component always? 15 sine 20. 15 sine 20 in this direction and t in that direction. 15 sine 20 minus t is equal to what? 1.5 times acceleration. It is 1.2. So is it 3.3? Tension equal 3.33 newtons. Right. Second question. No, they're asking resultant force acting on 1.5 kilogram mass. So what is the resultant force? I found tension to be 3.33. And, no. They're asking resultant force first and then tension. Mm, mm, mm. To find resultant force, we just apply F equal ma to this block. Without finding tension, we can find the resultant force on block. How? We know block is going in this direction with a 1.2 ms minus 2 acceleration. So the resultant force in that direction equal mass times acceleration. This is F resultant. මේක නේනම් අපි මෙහෙම මෙහෙම කරලා අඩු වැඩි කර කර දාන්නේ. This is the force we are writing as components like this. So it is resultant equal mass is 1.2 times acceleration is 1.2. So the answer is what? 1.8. If we found out this thing, then we can easily subtract this and find the tension also, right? It will become 3.33, obviously, right? I think you can understand. If you can't understand, just tell me. Don't keep things in your mind. Part C, mass of object X. Easy questions. So I will apply F equal ma to upward direction. Mass exert. To mass X, I will apply to upward direction, and upward force is T, and there is no any other force acting on. There is mg component. T minus. I will name the mass of this object to be simple. Mg sine 20 component. Mg sine 20 are the two forces acting on this object, equal to mass times acceleration. What is mass? It is just m times acceleration is acceleration 1.2. So we can write what is the tension. Tension we found 3.33 equal to m. I will take it out. I'll move this thing to this side and take out m. 1.2 plus g sine 20. G means 10 sine 20. What is the answer? 0.72. Is it correct? Correct. M is equal to 0.72 kilograms. So raise your hand if you did this question entirely correctly. No one. Those who understand this question now. Okay. So that's good. So you have to do question number 11. Question number 11 and then question number 12. 11 and 12. 11 and 12. If you completed question number 11 and 12, then do question number 14. Oh no, there is frictional force. Don't do it. No. There's a question asking, why can't we take 1.5 sine 20 equal to the resultant force? Ah, what is the result? I mean, what are all the forces acting on this object horizontally? This force and this tension force, right? These are the only forces acting on this object. So this is just a single force, right? 15 sine 20 is just a single force, and T is just another single force. The resultant is the vector addition of those two forces. Therefore, this minus this will be the resultant, right? So you can't directly take this equal to the resultant because there is another force. Resultant force means uh, if there is a force to this direction, if there is a force to this direction, F1 minus F2, if this is F1, if this is F2, F1 minus F2 will be the resultant of just F1 or just F2. I think you got it. Mm, I don't understand what you're saying. Mm, Sine Fernando. So, what do you call the vertical component? Is it 15 sine 20 or is it mg? 15 sine 20 is, oh, we call that component the, the sine component of its weight. It has no specific name because it is not the just force acting on that. 15 cos 20. 15 cos 20 is supposed to be the reaction force, right? Because what's happening there? It has a different story. 15 cos 20 is acting here, no? 15 cos 20 is acting here. And also, there is a cos component of this weight, this mass m. There's a cos component called m cos 20, right? For all two components, there is the reaction which is equal to m cos 20 plus 15 cos 20. So if they ask this reaction on this 1.5, it will be sum of these two, right? If I draw it clearly, I did this earlier also. So if you take it like this is the weight component. Sorry, this is the mg cos 20 weight component and it creates a reaction like this, mg cos 20. And in the same manner, it is the reaction to this action. So it is also mg cos 20. So it is the reaction on this small block. And then here it is the in capital Mg cos 20, which is the component of weight of the big block. And in order to balance all these two, the reaction on the bigger block will be capital M or simple M G cos 20. It will be the reaction, not a resultant or something like that. Always the resultant, there is no resultant force here. It is zero. If there is a resultant force to the perpendicular to the slope, it will fly, right? So it has no resultant, but resultant is in this direction, right? But now we are moving to question number 11. Question number 11. Right. There's an important point in this question. Everyone must listen. Much important point in this question. What is that? Right. Let me think. If I release from rest, this has tension T. This is the same string. This is not movable thing. So we don't need to mark tensions there. And this also has the tension T. This is the same string. And this also have the tension T. Will this have the same tension? No, this is a different string. Right. Okay. Those will have the same tension. Right. It is fine. So what we are going to do? I think the acceleration of this one is not visible. Acceleration of this one to be A, right? Acceleration of this one to be A. So if we think, if this travels the x distance, oh, it is not visible. Right? If this is traveling an x distance, it is traveling an x distance. Here it is traveling x over 2 distance and it is traveling x over 2 distance. Can you get that? Right? So if this is traveling an x distance, if this is traveling x distance, this part travels x over 2 and this part travels x over 2 because this is light inextensible string. Therefore, in order to balance the length of the string given by this has to go down. Okay, this will move down, but if it is moving down x distance, if it moved down x distance, this would have 2x change, right? The change in length will be 2x. It will be a contradiction, right? So if this is moving x distance, usually this will move x over 2 and this will move x over 2. Got it? Right? So if the acceleration here is a, acceleration of this pulley is a over 2, right? If this is a, this pulley has acceleration of a over 2, right? So I think it is an important point. Also, you can write it down anywhere. Calculate the acceleration of each masses. So we have to find acceleration of m1 and m2, right? We can apply F equal ma. F equal ma to m1. So we know to this direction, T is the only force, T equal m1 a. This is the first equation. And also we can apply F equal ma to this pulley. I will mark this pulley as P. To this pulley. Pulley is also a movable thing, right? If the pulley is fixed like this, we don't need to apply F equal ma. It doesn't have an acceleration. So, but this pulley have an acceleration, right? So if this pulley having an acceleration, definitely what will happen? Definitely we have to apply F equal ma for that. But there is a m2 mass. So m2g will be the weight and it must be equal to what? No, we can't say T equal to m2g. Can we say like that? No. If the pulley is moving with a over 2 acceleration, this is also moving with a over 2 acceleration. It is okay if you got this wrong, but listen carefully, right? If the pulley is moving down with a over 2, this must move with a over 2. Otherwise, it will be a contradiction, right? These are just strings, right? So if this is m2, this weight will be m2 and this tension will be T, but m2g does not equal to tensions, right? You have to keep that in your mind. I will take this to be T dash because I marked the earlier tension to be T, right? So what shall we do? We will apply F equal ma to P. the pulley. So I will apply in the downward sense because this is moving in downward direction. So if this is T dash, this tension will be T dash. This T dash is on M2 mass. This T dash is on M2 mass. And this T dash is on pulley. So T dash minus T plus T, it is 2T because T upward, so upward force is 2T equal to what is the mass of pulley? Oh, pulley doesn't have mass. Hmm. So we have to apply to the whole system, right? I thought pulley has a mass. So we have to apply to this whole system because pulley doesn't have mass. It means we can't apply Newton's law for an object which doesn't have a mass. Right. These are all fine. So I will apply F equal ma to all object, this all two objects, right? So F equal ma pulley and M2 to downward direction. So what are the forces in the downward direction? Do we need to consider this T dash and this T dash? No, as a system, they get cancelled out. And to the downward direction, only forces acting is M2G, right? M2G, and to upward direction, two forces are T plus T minus 2T equal to, what is the mass? It is M2. Acceleration is A over 2 because this whole part is moving with an acceleration of A over 2. If this moves a distance x, probably this will move a x over 2 distance. This pulley will move x over 2 distance. Then if the acceleration of this is A, this acceleration will be A over 2. Right. So we applied to the whole system because the pulley is massless. We cannot apply F equal ma to a massless object. So to a massless object. So we applied to the whole system and got this equation. This is equation number 2. And what are they asking about? Acceleration. So 1 plus 2. I will multiply this equation by 2, right? To cancel out these two. 2ma. So 1 plus 2, 2t, 2t cancel out, and m2g is equal to m m2ao2 plus 2m1a, right? 2m1a. So m2g divided by m2 divided by 2 plus 2m1 equal to acceleration. Correct. Who got this correct? And do you have any questions with regarding this? If you did this question correctly, raise your hand. And if you have any question, just ask me. Very good, Anju. So acceleration of m1 is this, and you have to divide the whole thing by 2 in order to get acceleration of m2. Yes, correct. Right. There are some students who got this correct. Good. And everybody, I think you can understand. If you can't understand, just tell me, right? These are the things you have to take to your mind. So do question number 12. Now you can understand things. Do question number 12. Right. I will discuss question number 12. It is easy because you know the theory there. Now, so yes, this diagram look like hell, but yes, we can do it. I'll mark the forces, tension, T. We don't know these things because these are fixed pulleys. No worries about forces. T, T, and the weight, 40 Newton, and yes, that's all. Right? About the horizontal forces, there are reactions and all of this, but these are the forces we just want right now. And if this moves with acceleration A, if this moves with an acceleration of A, This moves with an acceleration of a by 2, right? Will there be an acceleration of a by 2? No, because this is a fixed pulley. Fixed pulleys cannot move. If a length of x move through this pulley, it will always move this pulley also. Then, but the problem is with this movable pulley, right? Only here the acceleration become a over 2. So we can write down F equal ma. I will write fast to this direction. So t equal to 2 times a, first equation, F equal ma pulley to downward direction, 40 minus t plus t, 2t equal to 4 times acceleration divided by 2, right? So it is 2a. Second equation, and there it is 2t. I will multiply both sides by 2 in order to cancel. This become 4, and 1 plus 2, 2t, 2t cancel out, 40 remaining. 40 equal to 4a plus this 2a, 6a, a equal to, what is the value of a? 40 divided by 6, no? 6.66. Is it 6.66? 6.667 ms minus 2. Right. Those who got this correct, raise your hand. Good. Hmm? Cval acceleration. C means this. Cval acceleration means 3.3333. This acceleration is 3.33 minus 2. I found out the acceleration of A. Okay, I think others can understand. Yes, good. Do you want a lunch break? Right. So we will come back within 20 minutes, right? We don't have time to waste. We have to do much more questions. And after you coming to the class, I will start friction, right? It is a very important section, but it is very easy to teach you friction because you know everything about normal reactions. So if you know everything about normal reactions, it is very easy to do friction calculations. And I will start friction exactly at 1:05, right? Only 20 minutes. So be fast and teach it. Right. Okay. We'll meet at 1:05. 1:05, no, 2:05. Right? 2:05. Okay. So just take the interval and yes, we have to meet by 2:05. Right. Okay. So now I'm going to talk about, I think you can hear me. Yes, fine. So now I'm going to talk about different things. I told you earlier, this is a lift, right? This is an elevator. So in a lift, there can be a pendulum bob hung like this. And the lift is moving upwards. Let's say lift is moving upward with an acceleration of a, right? So if we write equations to this bob, considering we are here, what will happen? You will notice no acceleration in the object relative to you because you are having an acceleration of a and the object itself have an acceleration of a. So there will be no relative acceleration a, and you will see this pendulum bob to be having zero acceleration relative to you. But when we see from outside, if there is an acceleration of the elevator to the upward direction, there must be an acceleration of both this, there must be an acceleration of this pendulum bob to the upward direction, which is A, right? So, okay, right. So, one student just came, so I will explain again. So, if we look from this, right? If we look from this interior of this elevator, what will happen? You will see no relative acceleration of this pendulum bob. හරිද? අපි මෙතන ඉඳලා බැලුවොත් එහෙම pendulum bob එකේ acceleration එක පේන්නේ. But there is an acceleration actually. So we have to apply F equal ma always in a situation. We have to apply F equal ma only in a what? What reference? Inertial reference. Right? Okay. So this is the inertial reference. We cannot apply F equal to just looking at the interior forces because this is an accelerating frame. Therefore, we have to look from the outside. So let's see. That is thing you need to know. So let's see. What are the forces acting? This is an elevator and this is the pendulum bob. What are the forces? It is tension, it is mg. I need to find tension in some situations. I am taking situation number one. Situation number one. I'll take the situation to be, wait. Elevator is at rest. There is no acceleration. What will happen? F equal ma. I will apply F equal ma to upward direction. I will apply F equal ma to upward direction for the pendulum bob. So, what is the upward tension minus mg equal to mass m times acceleration 0. Then, what is the progress? T equal mg. That is the conclusion we can arrive. So, it is in equilibrium, no acceleration, no any forces, no any external forces acting. And then, moving with an acceleration of 4. No, I will take moving with an acceleration of a. What will happen? We are looking from outside. Then this also have an acceleration of a to the upward direction. So if we take this, so this will have an acceleration to the upward direction. I will apply F equal ma to the upward direction. T minus mg is equal to m times a because this is in upward direction. Acceleration is in upward direction. T equal m common g plus a. Right? If we think acceleration to the downward direction, what will happen? In the third case, I will apply F equal ma to the downward direction. So think about the forces. Downward mg. mg minus t is equal to mass times acceleration is in downward direction. So tension equal to mass g minus a, right? If it is moving with upward direction, g plus a. Downward direction, g minus a. Acceleration is mg. That's it. If it is at rest, t equal mg. And yes, now I need you to do question number 4. Do it quickly. We have to move on to some important things. There is impulse and then linear momentum, friction. Just do it. Question number 4. I'll start to do the question. It is very much easy. The spring balance is suspended from the ceiling of an elevator and an object of 6 kg is attached to it. This is 6 kg. And reading of the spring balance. Reading of the spring balance means it is the tension they are talking about. What else? So, first one, elevate at rest. Elevate at rest, we know from the previous experience, mg is equal to T. So, T equal to 60 Newton. This is equal to 60 Newton. Right. Second, moving upward with constant acceleration of 4. So, second, F equal ma to upward direction. T minus 60 equal to 6 times acceleration is 4. T equal 84 Newton. Then third one, down upwards with deceleration of 3. Upwards with a constant deceleration of 3. මොකක්ද ඒ කියන්නේ? to upwards lu යන්නේ හැබැයි deceleration එක 3. මොකද කරන්නේ? Yes, acceleration will be minus 3. A equal minus 3 කියලා ගන්න පුළුවන් අපිට. Just easy. So F equal ma to upward direction, upward force is T minus 60 equal to mass is 6 times acceleration is minus 3 because it is moving with deceleration to upward direction. So T equal to 60 minus 18 is 42 Newton. Fourth case, with a uniform velocity, acceleration 0, then again mg is equal to T. Fourth case, no need to do any calculations, T equal to 60 Newtons. And fifth case, moving downwards with constant acceleration 5. So downwards with constant acceleration 5. Downwards with constant 5. So if we equal ma, downward direction 60 minus T equal mass is 6 times downward 60 minus T, yes, 6 times 5. So T is equal to 60 minus 30, 30 Newtons. Sixth one, falling free under gravity. We are sixth one, F equal ma to downward direction. Downward force 60, 60 minus T is equal to mass is 6 times acceleration is downward 10. So 60, 60 cancel out, tension will be 0. That is very much important, right? That is an important thing. Tension will be 0 when it is falling under gravity. Constant, no, move it downwards with constant acceleration 3. I will write it here, VII. Downwards with constant acceleration, constant deceleration 3. So it is minus 3, right? If we equal ma, downward direction 60 minus T should be equal to mass is 6 times minus 3. T should be equal to 78 Newton. Very easy. Yes. I'll give half a minute. We have to go quickly. Then come to page number 11. Come to page number 11. Right. There is a section called elevator problems, and Here it is talking about a man standing there. And the force he feels. What is the change in force he feels? It is the normal reaction, right? Because the weight is always there. Weight of the man is always there. There is a normal reaction to the man, which is R. At rest, what is happening? Mg is equal to R. But it is moving at constant acceleration to upward direction. What we do? Apply F equal ma from exterior point. I am watching from here. Right. So F equal ma upward direction R minus mg equal mass times acceleration. So R equal mg plus a. Same scenario, ne? What is happening? We have to keep this in our mind. This is a shortcut. So if it is moving with acceleration a, reaction or tension or anything, reaction or tensions, we can get it as mass times g plus a. If it is moving with deceleration, this is acceleration to upward direction, right? Acceleration to upward direction. And now I am considering acceleration to downward direction. RT anything equal to mg minus a, acceleration to downward direction. And if acceleration equals 0 or constant velocity, t is t or r equal to mg. And if acceleration is equal to g and it is falling down, tension or reaction equal to 0, right? That means if we are going in a lift of Nelumkuluna, right? That Lotus Tower, if you are going in the lift and suddenly the cable will disappear, right? What will happen? You will feel that thing called that normal reaction will be 0 and you will feel something you never felt. Okay, so හරි. දැන් තමයි මේ නිින්ද යාගෙන එන ටයිම් එක නිදාගන්න නම් එපා. දැන් තමයි හොඳම දේවල් ටික වෙන්නේ. So you have to note these things, right? You have to note down these things because they are very much important. That is the thing. The reaction is changing. What is happening when it is accelerating to the positive direction? You feel you are very, very. I mean, no, not light. It is. It is a light. It is yes, yes. It is like this is the thing. Reaction is very much greater. 아무도 දේවල් ටික ෆීල් වෙනවනේ ලිෆ්ට් එකේ ඇක්සලරේට් කරද්දී ඔය යටට මේ උඩට යද්දී ඩීසෙලරේට් කරද්දී ඔය ටික තමයි ලියලා තියෙන්නේ. Yes. 10 වලට ආවොත් if it is falling with g, what will happen? You will feel 0 reaction, right? You will feel 0 reaction. Right. It is discussed in page number 11. Right. We are arriving at a very important topic, friction. We have to do this very quick. Friction. Page number 7. Page number 7. Right. Listen carefully. This is a very important section. You have to listen very carefully. Right. What is friction? Friction is the what? Resistive force, which is acting opposite to the motion, right? If there are two surfaces, I don't explain the basics, right? If there are two surfaces, if it is moving an acceleration to this direction, surely if this surface is rough, there will be a frictional force to the opposite direction which opposes the motion, and we call it a resistive force, right? Okay, so there are three types of frictional forces. What are they? Static friction, static friction, limiting friction, limiting friction. Third one, dynamic or kinetic friction, right? There are three frictional forces: static friction, limiting friction, dynamic friction. So, right. Static friction means what? The frictional force acting on an object when the object is not moving. When the object is at rest. Rest එකේදී තමා මෙන්න මේ වැඩේ වෙන්නේ. Static frictional forces act when the object is at rest. Good. Limiting friction. We know that if I apply a force to this calculator, if I apply a force to this calculator, it will not move. I am applying a force. You can't see. I am applying a force to this calculator. It will not move. It will not move. At some point, it will start moving, right? What is happening? If I draw a block like this, and I will apply a force of 1 Newton to the block. It will not move. What is happening? Friction is creating a 1 Newton frictional force, right? I apply 2 Newton. Just it is not moving. Why? Here friction is balancing by increasing its value to 2. Again, 3. It doesn't move. 4, 5, 6. At some point, it becomes to the urge of moving, right? Urge of moving. Moving, not. Moving, not. There is a point, right? That point is called what? That point is called limiting frictional force. එතකොට ඒ point එක act වෙන්නේ මොකද්ද? Limiting frictional force. The frictional force which is acting at that point, we call it limiting frictional force. I thought you know limiting friction. What is limiting friction? That's why I am going somewhat fast. So this is urge of moving. And kinetic or dynamic friction, it is moving objects. Then friction කිව්ව ගමන් අපිට මතක් වෙන්නේ මොකද්ද? What is the thing we remember when we talk about friction? F equal mu r. That is the only thing we remember. But that is not the thing in friction. We have to understand this properly. We cannot apply F equal mu r for what? Dynamic friction, limiting, dynamic. There. No, you cannot apply for this. Static friction, you cannot apply F equal mu r. How can you apply? If you give coefficient of, I think you know what is mu is. Mu means coefficient of friction. F equal to mu times r. I think you know this. Mu means coefficient of friction. This is normal reaction. This is the frictional force, resistive force, right? If we think we give a force of 2 Newton to this block, what will be the reactive force? If this block is not moving, what will be the frictional force? Again, 2 Newton will be the frictional force. If we consider the coefficient of friction between two surfaces is 0.7 and this object is 5 kilogram, this has a, what is this frictional force? F equal to mu r, I will apply F equal to mu r, right? Then mu means 0.7 times reaction is what? 50, right? Reaction is 50 Newton to the upward direction. 50 equals what? 35 Newton. 35 Newton. If I apply a force of 2 Newtons and it will apply a force of frictional force of 35, what will happen? If I apply a force to this direction, it will start to move like this. It's like Holman thing, right? No ghosts in physics. What will happen? It will just balance our small force, right? Until it comes to the limiting position. From limiting position, we can apply these equations: limiting position and dynamic position. For limiting and dynamic positions only, we can apply F equal mu r. Can we apply static friction? No. We cannot apply F equal mu r for static friction. That is the most important thing. Most of the students think about F equal mu r when they are looking at a sum of friction, right? So, in page number 7, friction is the resistive force. I told you. There are three types of friction: static, limiting, dynamic. I told you now, right? Static, we call it Fs usually, limiting Fl, dynamic Fk, right? There's the notation given. Loss of friction. This is much important. Friction depend on nature of surfaces. Is it true? Yes. If the nature is very much rough, then the frictional force is much greater. And then second one, friction is independent of area of contact. Is friction depending on area of contact? No, it just depends on nature of surfaces. It doesn't depend on area. It is also in the O-level syllabus, I guess. Limiting friction is directly proportional to normal reaction, right? It is correct. And also kinetic friction is directly proportional, right? Mu is the coefficient of friction. It is a dimensionless constant. R is the normal reaction. We know the equation F equal mu R, and we know, can we apply it to static? No, we can apply it to only dynamic and limiting conditions. Okay. Critical warning. F equal mu R trap. The formula F equal mu R is only valid when object is in limiting equilibrium, just about to move, just to move, urge of moving, and already sliding, which is kinetic equilibrium, kinetic friction. Yes, I think now you can understand those things, right? Isn't it? Okay. And for any other state where the object is stationary, friction Fs means static friction is less than mu r. It is correct, right? Static friction is less than mu r. It is less than 35, right? It is just 2 newtons. It is less than mu r. So, do you know this? Do you know this? If I draw, if I draw frictional force Fr with the applied force, I am applying a force of F newtons. I am applying a force of F newtons, and this is the what frictional force. So if I apply 1 newton, what will be the frictional force? 1 newton. 2 newton, I think this is not moving. 2 newton. Right. 3 newton. 3 newton. Up to one point, it is increasing linearly, right? Get it? Up to one point, it is increasing linearly, and the topmost point, we call it what? Limiting friction. Limiting friction. Up to that point, what is this region? Static friction. This is limiting friction, right? So limiting friction is the highest friction value one can reach, an object can reach. It is in the urge of moving, and it is the highest friction one object can reach. So the dynamic friction is slightly lower than, this is dynamic friction. It is a constant, right? It is just mu r, not no any other. So it is a constant, and this dynamic friction is slightly less than limiting friction. Have you ever thought about this? When we are moving an object, it is difficult to initiate the motion, but after that it is easy, right? Have you experienced that? That is because limiting friction is a bit greater than kinetic friction. Mu r. Mu r means if they have given mu k, it is kinetic friction. And if they have given mu s or mu l, I have given it as a point. Always mu s and mu l, we take it to be the same value. If they have given what? If they have given mu s, We can take it as mu L also for limiting condition. But can we take it as kinetic? No, we cannot take as kinetic. We can take mu S and mu L to be the same value, right? Mu S and mu K to be the same value. So if they ask you to find out the friction, limiting friction equal to what? Mu LR, or it is also equal to mu SR, mu static, right? Get it? And if they ask kinetic friction is equal to mu K R. I need you to answer this question. Is mu L or mu S or mu K? I will, mu L is equal to mu S, no? So I will just ask mu L greater or mu K greater? Is mu L greater or mu K greater? So chat is open, so you have to answer. What is the greater? Mu L. Yes, mu L is the greater because this force is greater than this force, right? If L will be greater than Fk, normal reaction is same for both. So mu L is greater than mu K. It is given in the tutorial. Mu K is less than mu L, right? And mu L, mu K, limiting kinetic, they have given. And notation note, in most mechanics problems, the coefficient of static friction, mu S, and coefficient of limiting friction, mu L, referred to as the same value. Can you understand everything under friction? Right. Now you know how to take reactions. And now you know what are frictional forces. Then you can solve any problem in friction base. Understood? So there is the graph given. So you have to note down these things: static, limiting friction, and this is dynamic friction. Dynamic friction, and yes, yes, it is. It is friction. Just note down this, and we will move on to questions. Do question number 50. Do question number 50. නිදාගන්න එපා. හොඳම සීන් එක යන්නේ දැන්. right. කාලා කාලා එලා නිදිගන්න ගන්න. You have to do this question within 3 minutes. You will get less than 2.5 minutes to solve this type of question in A-levels.
If you are done, raise your hand. One point seven three. You need to remember those things. Root 3 equal to 1.73. Those things you have to be in your mind. Root 2, root 3, root 5, root 7. Those things you have to keep in your mind. No, those things. Raise your hand if you completed the question. So you can do question number 6. No, question number 5. If you completed question, do question number 5. Try it. It's a good question. Think about the forces and where that forces are acting, right? On which object the forces are acting. Consider the forces acting on a specific object when applying F equal m. You have to keep that in your mind. Question number 5 around here. Right. I will discuss this question. And if you haven't got it correct, just look at this. Right. I'll mark the forces. Here it is 100 newtons, tension, tension, and this must move in which direction? You have to confirm that first, right? You have to confirm whether it is moving this direction or it is moving this direction. So, how to confirm that? You have to look at the component of weight. Here the weight is acting 200 Newton and this is 200 sine 60 and this is 200 cos 60, right? It is 100 newtons, right? It is 200 sine 60. So which is greater? 200 sine 60 means 100 root 3. Root 3 value is 1.73. So this is a greater value. It means it is 173 newtons. So acceleration will be to this direction, right? It is the thing to notify first. Right, I will apply F equal MA to this 10 kg to upward direction and it is T minus 100 equal to 10 times A. This is the first equation. So what is the other force acting here? Before friction, this is true, right? Okay, right. So what is the direction of friction? Yes. This is the direction of friction. I mark it as FR. So FR equal what? No, before that, R equal what? 200 cos 60. The normal reaction R is equal to 200 cos 60. Equilibrium. 200 into half equal 100 Newton. So if we apply F equal mu R, so we can find out this frictional force. FR equal mu R, mu value is given to be 0.2. 0.2 times reaction is 100, which gives 20 newtons, right? 20 newtons. So what shall we do? Apply F equal MR, F equal MA to A block. F equal MA 20 kg block. So here it is 100 root 3. It means 173 Newton to this direction. And it is a weight component. Here T plus FR minus T minus FR. Can you understand this? They are in the opposite direction. So we are applying this in the downward sense, downward along the plane. FR equal mass. What is the mass? 20. 20 times acceleration. It is 8. 173 minus FR we know 20. Minus 20 minus T equal 28. 153 minus T equal 28. So this is the second equation. So we need to add equation number 1 and equation number 2. You get 53 equal to 30A and acceleration will be 53 over 30. 1.76 seconds. 1.7. Right. They are asking the tension. This is in a. So I will substitute to equation number 1. T equal 100 plus 10A. 100 plus 10 into A, 17.7. So 117.7 newtons is the tension. So who got everything correct? Raise your hand. Those who got everything correct, raise your hand. Good. Is it just two? No. Others, do you have any questions? Who understood? If you have any questions, go to the chat. Anyone who have completed question number 5 also can do question number 14. Question number 14. Yes. Raise your hands if you have completed question number 5. Others? If you completed 14th question also, move on to the last question, question number 17. After 14, 17. I'm waiting till majority of you raising your hands. Make sure to do the question. Right, I will explain the question. If you haven't solved the question, listen carefully. Right. The question says, a man of 60 kilograms stand on a wooden platform of mass 30 kilograms. Wooden platform has a mass of 30 kilograms. The platform is suspended by an multi-pulley system shown in the diagram. This is like this. Okay. And light inextensible string passes over fixed pulley and support the movable pulley. Right. So question number 1. Right. Before question number 1, I'm going to mark the forces. Always the weight of the platform, it is 300 newtons. Right. It is 300 newtons. Right. Weight of the man, it is also acting on the platform. It is 600 Newton. Right. Weight of the man is 600 Newton acting on the platform. Right. Again, let me take this tension to be T, a single tension to be T, because they are asking the tension. Force the man exert, it means the tension. It is T, then this is obviously becoming T because it is the same string. And then if it is in equilibrium, it is not a moving system. So it is in equilibrium. That is, here the tension is T, here the tension is T, and this tension is what? 2T, because it is the addition of these two forces, because the pulley is in equilibrium. So the downward forces must equal to upward forces. So this is 2T, this is 2T, and this is upward 2T. Right? I think you got that. That is an important point. Right. So is that all? All the forces acting on the what? Platform. Right. Do we care about the forces acting on the man? No, still no, because we are going to apply the equilibrium principle for platform. Equilibrium means there is no acceleration, there is no movement, right? If there is no movement, upward forces must equal to downward forces. So forces to upward direction equal to forces to downward direction. I'll take the platform. Platform. We know 300 Newton and 600 Newton are the downward forces acting on the platform. 600 downward, this side is upward. Upward T, again 2T. It is 3T. Why we don't take this T? It is acting on the man. It is acting on the man. Why we take this T? Because we are applying equilibrium to platform. Just 3T equal to what? Equal to downward weights 300 plus 600, right? So T is 300 newtons. Right. Second question, normal reaction between man and the platform during equilibrium. Now we need to consider the forces acting on man. Man has the what? Weight. He has the weight. It is 300. He has the weight. It is 300. And this weight is acted upon the what? Platform. This weight is acted upon the platform and it gives a normal reaction to man. I will draw it in black color. It gives a normal reaction to man equal to what? 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 No. Normal reaction කතාවක් නෙමෙයි යන්නේ. එයා මෙතන ඉන්නවා කියන්නෙම එයාට යටට ඒ force එක act වෙනවා. Yes. You are telling like no. Why? Always හරි මට දැන් ඔයා අහන දේ තේරෙනවා මොකද්ද මෙතන weight එක 300, the weight is 300 and you are saying 600 weight is 600 and you are saying that if he is pulling that rope then he will not exert this exact 600 on the platform. This is what you are saying. No, it will happen. He will exert the weight, but the reaction will be different, right? The reaction is the thing which is getting different. Understood? We will solve some questions. Yes, we will solve some questions within these 3 days. So you will understand these concepts, right? In equilibrium, we will
we will solve these types of questions. So you will understand, right? Okay. So up to now, who got this 300 Newton as answer? Upward force here should be 40. How it must be 40? Because this is T, this is T, they are acting, this is T, this is T, and this is 2T. It is okay. This tension is acting where? This tension is acting upward towards, I mean, it is acted upon the man, right? It is not acted upon this platform. It is not acted upon this platform. We are taking the forces acted upon the platform. So this T, we have to neglect that tension value. So just forces are these things, right? So try, I will solve the other two questions also. Try question number 14, and if you have done 14, 17, right? Quickly. So there's a confusing point with question number 5, and I will discuss question number 5 along with equilibrium. So I will discuss the key concepts related to equilibrium, and there are many pulley systems in that section. So I will discuss question number 5 with that. Okay, don't get confused and just do question number what? Question number 14 and 17. The question number 14 and 17. Right, I'll do question number 14. Look at this. This is a tricky question, and yes, we need to do this. It is the law. Right, and the length is given as length of the rope is 10 meters and it is 2 kilogram. It talks about a heavy rope, heavy string. Right. So, question: a block of mass 8 kilogram is accelerated at 2 ms minus 2. It is accelerating. The system is accelerating at 2 ms minus 2. Right. Along a rough horizontal surface with coefficient of kinetic friction 0.1, mu k equal to 0.1. Right. This is achieved using horizontal rope of mass 2 kilogram and length 10. What is the force F that should be exerted on the NA of the rope to pull it? මොකද කරන්නේ? System එකටම F equal MA දානවා. මෙන්න මේ මුළු system එකටම F equal MA දාපුවාම only external force acting is this and what? The frictional force. So they are exactly frictional force acting into this direction because it is moving to right side. So friction must act at left side. So frictional force I mark it as R and normal reaction I mark it as R. So we know R is equal to mg. R equal to mg. So R equal to what? 8 kilogram, right? So 80 newtons. So we can apply F equal mu R. This is a moving condition, kinetic friction. We can apply F equal mu R into 80. It is 8 Newton. The frictional force is Fr is 8 newtons. So we will apply F equal ma to system. When you consider in the system, there are no other forces other than this frictional force and capital F. So I will apply to this direction capital F minus frictional force equal to total mass. Now you need to consider 2 kilogram mass, right? Because this is also a mass of the system. 2 plus 8. 2 plus 8 is the total mass times acceleration is given to be 2 ms minus 2. So F minus friction is 8 equal to 2 plus 8, 10. 10 into 2, 20. So F is equal to 28 newtons. Force is equal to 28 newtons. I hope you can see it. Right, force equal to 28. So now in the second section, what is the force exerted on the block by the rope? Now think, what is happening? What is the force exerted on the block? On the block means, this is what he is asking, right? Force exerted on the block by the rope. This is the force they are asking. Here, I name it as F naught, and same Fr friction is acting. And yes, these are the two horizontal forces acting on the object. So what shall I do? I will erase this one. What shall I do? F equal ma to block. F equal ma in this direction. So what is that force? F naught. F naught is the force on the block. Now you know those things. Minus Fr equal to ma. Mass we know what? 8. 8 times acceleration 2. So F naught minus Fr is 8 equal 16. F naught equal 24 newtons. Those are pretty much easy questions. F naught tension, comma, but you can do it like this, no? Because now you know force on the block is tension, right? Force on the block is tension, but they're asking force on the string. It is not tension. It is the opposite one. Right. What is the tension at the middle point of the rope? Good question. Solve that question. Solve the third part. It is a good question. Now you know how to deal with heavy ropes. So do question. I will erase. So what shall we do now? In the question, they are asking, what is the tension at the middle point of the rope? If I draw it like this, here it is friction, here and here. So how can you divide the rope? So we can mark tensions like this. Can you remember? We can mark tensions like this. I take this tension to be T1, right? So what is the other force acting? F, right? These are all forces acting on the block, right? And also they are moving with
2 ms minus 2. You can apply F equal ma to find T1 either to this block, either to this section or this section, because this T1 belongs to this section, right? And this T1 belongs to this section. Understand? So how to apply? I will apply to both and show you. We will get the same answer. I will apply F equal ma to this direction. Here, what is the force? I will isolate this one and apply F equal ma. The force is T1, right? Minus Fr equal to mass. What is the mass? 8. Acceleration 2. T1 minus 8 equal to 16. T1 equal to 24 Newton. Neither Fr is 8 ne? I will apply to this section also. F equal ma to this. F minus F is the force to this direction. F minus T1 equal to mass is I'm wrong. Why? I took the mass as 8. Is it 8? No, 8 plus mass of this section. What is the mass of this section? Rope is 2 kilogram ne 2 kilogram නම් 2 kilogram නම් කීයක්ද වෙන්නේ 1 kilogram ne, so this has to be 9 into 2, it means 18 plus 8 26, right? So I will apply F equal ma. F minus T1 equal to what? 1 times 2. It is 1 kilogram because I am applying to this section. So force is what? What is the force? 28 minus T1 equal to 2. So T1 equal to 26 newtons. T1 equal to 26 newtons. So we got the tension at this point. Now you can do question number D. Question D. Do part D alone, because now you know how to do these types of calculations, right? Yes, do question. I'm asking you to do because only if you solve questions you will get practice to that. If you do only theories, you will never practice to do questions. You cannot apply a theory to questions, and yes, therefore you have to know. From point A, right? Take point A to be here. Point A is to be here, right? They are not mentioning about the point A. No, in the A part, they are asking point A is here. Read the A part. Point A is here. End of the road. Quickly do and raise your hand. Quickly do the part D and raise your hand if you complete it. Be quick.
On the message. If you did part D, raise your hand. Now you can do it. So do it quickly and raise your hand. So shall we do that? They are asking in the D part. In the D part, right, tension at the string 2 meters from the point A. This is just 2 meters. This is a 10-meter long wire. And they are asking 2 meters from point A, right? It is right here. So if the 10-meter wire is 2 kilograms, what is the mass of 2 meter? 2 divided by 5 kilograms, right? It is divided by 5 now. So it is 0.4. Okay, so what we need to do? Just apply F equal MA. This is not a hard question because you did the previous question and now you know how to do that. So apply F equal to MA to this direction to what? This piece of this piece. Yes, this is the tension. I take it as T2. This is the tension on the other side. This is also T2. So F is to this side minus T2 equal to mass is what? 2 over 5 times acceleration 2. So F is what is the 28? 28 minus T2 equal to 4 over 5. 4 over 5 means 0.8. So T2 should be equal to 27.2. Next, 27.2 newtons. It is the answer. Those who got correct, raise your hand. Physical lamai hundai, online lamai. Who got correct? Others, are you sleeping? Everyone, hands up. So I can know how they are doing that. Okay. What about Neha and Aniha? Hmm. Okay, fine. So good, but you have to do the questions. You need to do the questions. You need to practice the questions. It is the thing which make this effective, right? Now we are going to do a brand new section, right? We are going to do a brand new section. Brand new section, right? It is impulse, right? It is impulse. Right. Right. Okay. So what is impulse? මොනවගේද impulse කියන්නේ? Instant force. Good. So online students, what we call an impulse? Any different answers? Impulse is a force applied in a specific small amount of time, right? If we say we are hitting a ball with a bat, right? If we say we are hitting a ball with a bat, it will happen in milliseconds, right? It will not take even a second. It will happen in milliseconds, right? Therefore, force applied within a very small time period, we call it what? An impulse, right? So turn to page number 6. You will find the topic impulse. Impulse is a vector quantity. It is important. Impulse is a vector quantity. So we have to consider directions when taking impulse. Quantity describe overall effect of a constant force acting for a period of time. එතන ඉන්නවනේ small period of time කියලා. Period of time නෙමෙයි smaller period of time. Right, correct that. Impulse is defined as product of මේක ඉතින් මතක තියෙන්න ඕනේ. Impulse equal what? F delta T. F delta T. This is the force acting. Force acting. This is time period. මතක තියන්න අමාරු නෑනේ. We can remember these things. මොකද්ද? I equal F delta T. Impulse equal F delta T. Right. දැන් මෙහෙම එකක් තියෙනවා. මතකද මේ equation එක? Do you remember this equation? F equal mv minus mu divided by t. Do you remember this equation? What is this? F equals ma. We derived F equals ma from this. Right. Right. Okay, so what we were discussing was F equal mv minus mu divided by time. So if I think this equation for a shorter time, I can write it as delta F equal mv minus mu over delta t. You don't want to think about this. Just think I can multiply these two sides, no? Then it is F delta t, right? F delta t equal mv minus mu. What is F delta t? It is impulse. So I equal mv minus mu. බයිලා නෑ මෙච්චරයි කතාව. හරිද? මතක තියෙන්න ඕන මෙච්චර. You have to remember this exactly. When a small force is acting, what is it? An impulse. And I equal F delta
t, and again I equal what? mv minus mu, which is what? Rate of change of linear momentum, right? Rate of change of linear momentum. So yes, it is the major thing, right? So again, there is a thing called force time graphs in your syllabus, right? Force time graphs, FT graphs, force versus time, force versus time graphs. So if we consider a force versus time graph like this, right? What is the area of force versus area time graph? It is the impulse. Impulse equal area. Also, we can write it as what? Area equal to what? Change in linear momentum. Why? Impulse equal F delta T equal change in linear momentum. You have to remember that. So, FT graph, when you see a FT graph, area represent what? Impulse, and also it is equal to change in linear momentum. You have to remember this. You don't need to study these things, just remember, right? I told you earlier, impulse is a vector quantity. Do you remember? Impulse is a vector quantity. So, if we note a graph like this, F versus T, and it is like this. So, what is the resultant impulse? I will take this area to be A1, this area to be A2. What is the resultant impulse? T1 minus T2, A1 minus A2, because we have to consider this negative part, negative side as negative. Why? It is a vector, right? Because it is a vector, this is A1 minus A2 is the resultant impulse, right? Okay, so yes, they have given under sign convention. Yes, those all of those things are given in the page number 7. There is area and direction. Yes, area above the time axis is positive and area below the time axis is negative. So total impulse equal algebraic sum of those areas. Algebraic sum means the positive area minus negative area. Right? Can you understand this thing? Can you understand? Yes. Okay. So, right. I will solve an example. Hmm? Right. There's a question like this. A ball of mass 100 gram strike the ground like this. It comes like this and it moves like this, right? Here it is 30 degrees and here it is 60 degrees. And the incoming velocity is 10 ms minus 1, outgoing velocity is 8 ms minus 1. So this weight of this ball is 100 gram. 100 gram, right? So they are asking what is the impulse? They are asking what is the impulse? So as F equal ma, this also can be applied to a specific direction, right? So there is a there is a horizontal impulse and vertical impulse. So you have to find both of those, right? So I am applying impulse horizontal equal to, can we apply F delta T here? Why? There is no force, no delta T given. So we can apply what? Change of linear momentum, right?
horizontal, we can apply in this direction. So mv minus mq. It means v is what? Final velocity. So mass we can take out 100 grams means into 10 to the power minus 3 in order to convert into kilograms. And v minus u, v horizontal component. What is the horizontal component? 8 cos 60 में sin 60. 8 sin 60 in this direction, right? Minus what? U. 10 cos 60 में है sin 60 में है. 10 sin 60 sin 30 in which direction? In which direction? It is also in this direction. Understood? It is also in this direction. Good. Now what we can do? Take the vector sum. Right. Think if it is a situation like this, right? If it is a situation like this, it is like this. It goes here and goes like this. So the velocities are, the direction of velocities are different. So I will tell you how to do these types of questions also. But up to now, we can just simplify this. So how to simplify? 100 into 10 to the power minus 3. 8 sin 60 minus 10 sin 30. 8 sin 60 means 4 over 4 root 3. 4 root 3 minus 10 sin 30. 5. I'll take the answer. 4 root 3 means 4 root 3 minus 5. So it is 1.93. 1.93. And it is also in this direction. So 100 into 10 to the power minus 3 into 1.93. So what is that? 1 point. Yes, root 3 is 1.73 now. Then this is greater than 5, right? 1.73. It is closer to 2, it is closer to 8, right? So 1.93 is the answer here. And it is multiplied by what? 100 into 10 to the power minus 3. So you will get the answer 193 into 10 to the power minus 3. 193 into 10 to the power minus 3 to which direction? It is positive. So it is the exact same direction we thought about, right? So is it okay? Is it all over? No. What shall we do now? There is the vertical component also, right? There is the vertical component, right? Wait. First, you need to find vertical here, horizontal impulse, and then you need to find vertical impulse, right? Then you can do anything, right? First of all, you have to find the impulses in both directions. So I will write impulse vertical. I will consider that in downward direction. Any direction you can consider, but the things are getting different slightly. Final answer is same. Then I vertical equal mv minus mu. Okay. M common v minus u. That is also okay. Then what is the mass? 10 100 into 10 to the power minus 3. That is right. So velocity, final velocity, it is upward 8 cos 60. 8 cos 60 upward. We are taking it in down. 8 cos 60. Where? It is upward. So we are taking the equation downwards. So I will name it minus 8 cos 60. Is it okay? Right. Minus u. U is 10 cos 30, but it is also what? Positive. Why? We consider downward direction, and also it is in the downward direction 10 cos 30. Right. So what is the answer we are getting? We are getting 10 cos 30 is plus. What is this negative sign? It is a negative sign of the equation. So if this is a negative value, it will become plus, right? If this is also in the upward direction, we are writing this value u as a negative value. Minus into minus, it becomes plus, right? So here, direction is important. No, selecting this direction is not important, right? Only the direction is okay, right? 8 cos 60 plus 10 cos 30. 12.67. 12.67, but negative. Negative 12.67 into 10 to the power minus 1. Right? Okay, so it is in which direction? In downward direction, minus 12.6 into 10 to the power minus 1. So what is the direction of impulse? So I vertical is in upward direction 12.67 into 10 to the power minus 1. So what shall we do now? We have horizontal impulse, what? This thing, and vertical impulse, this thing. So what shall we do now? Take the result. Vertical one, I will take it as 12.67 into 10 to the power minus 1, and this one 190, I take it as 1.93 into 10 to the power minus 1. Right. I'll solve. How we can solve for the resultant? Resultant impulse, I'll take it as Ri. Resultant equal to root of 1.93 into 10 to the power minus 1 whole square plus 12.67 into 10 to the power minus 1 whole square. Right? Can you understand? You will get these types of simplifications also in the second paper, not in MCQ paper, but in second paper you will get these types of simplifications. Can you understand? I need a reply from online students. Can you understand this? If you understand, please raise your hand. And if you do not understand, just send me a message so I can explain again. I think you can understand now. Pujani Pereira, what about you? Are you okay? Yes. And Aniha. Right, perfect. So you can solve question number 16 now. Question number 16 now. You don't need to write this one, but just do question number 16, right? Yes, 16. Yes, question number 16. අඩ ඌ නවත්තන්න කියලා නවත්තන්න නෑනේ කියලා හිතන්න එපා. නෑ නෑ. නවත්තන්න පුළුවන් ඉතින් මටත් ඉවර කරලා යන්න පුළුවන්. ඒක නෙවෙයිනේ මෙතන වැඩි. දැන් ඇනිලා තියෙන එක කොහොම හරි ගොඩ ගන්නනේ හදන්නේ. ඒකින්ද අනිවාර්යෙන්ම මේක හරියට කරගන්න. මේක කරොත් ඇත්තටම ගොඩක්. දැන් නිව්ටන් ටික මට තේරෙනවා ඔයාලා වැඩේ කරගෙන යන්න පුළුවන්. questions ටිකක් තමයි MCQs ටිකක් practice කරොත් ඉතින් පස්සේ වැඩේ අවුලක් නැහැ. got a impulse and then we will start today linear momentum and work energy power.
If you completed question, please raise your hand. It is an easy question. Yes, it is. Good. So you can do question number 13. Do question number 13. I am giving you time to solve the question. If you are not solving the question, you're just you can't increase your potential to do questions. So try to do the questions and check with check with me, right? Those who finished question number 16, please raise your hand. Everyone must be able to do that question. Good. I will wait until everyone raise their hands because this is a easy section. So you have to practice the questions. Otherwise, there will be no use of this. Those who finished, send me the answer to the chat. Send me the answers. So that one sent me. So I need your answers. Right. I will solve the question. Listen carefully. I will solve step by step. If you can't understand anything, just ask, right? Don't keep that in your mind. Just ask me and clarify everything. Right. The question is like this. The ball comes and goes like this. Okay. So it comes with 10 ms minus 1 like before. 8 ms minus 1. This is 60. This is also 60. Right. And it tells ball is 100 grams and strike for 4 into 10 to the power minus 1 seconds. Right. First, they are asking impulse. We have two equations. I equal F delta T. So here we know only what? Time. So we cannot apply this. So we know another thing. I equal change in linear momentum delta mv. So we are applying the second equation to find out impulse. I am applying horizontally to this direction. I equal mv minus mu. M common v minus u. Right. M is 100 into 10 to the power minus 3. It is 0.1 times final velocity horizontal component. What is that? 8 sine 60 minus what? Oh, from this we have to take what? Horizontal component. 10 cos 60. So 10 cos 60, it is 10 sine 60, right? Okay. Then 0.1 times 8 minus 10, 2. 2 sine 60 means 2 into root 3 over 2. 2 cancel out. 1.73 into 0.1, 0.173 Newton seconds, right? how this came from? It came from this equation F delta T Newton second, right? It came from that equation, right? Listen. Now we are going to apply I equal delta MB minus MU to what? Upward direction, right? Upward direction I equal 0.1 times V minus U. V means 8. This is the final velocity. 8 cos 60. 8 cos 60 to the upward direction. No worries. Minus, this is to the downward direction. And we are considering upward direction. We are considering upward direction. And this is to the downward. So, simplification. It is minus, no? It is minus. So this is also minus. Minus 0.173. Sorry. This is 8 minus 10 is minus 2. Right. Now, here, the initial vertical velocity. What is the initial vertical velocity? 10. What? Was 60. But to which direction? To downward direction. What is the direction we considered for impulse? Upward. So this will be minus what? 10 cos 60, right? So 0.1, 8 cos 60 minus into minus plus 18 cos 60. Cos 16 is what? Half. So it will be 0.9 Newton seconds. Right. So what do you need to do now? Impulse resultant equal to 0.173 whole square plus 0.9 whole square. And also, what is the direction? Impulse is in this direction, negative this way. So it is in this direction, 0.173 Newton seconds. And in the upward sense, 0.9 Newton seconds. It is in the resultant impulse is in this direction. I think you can understand, right? So what is the value? What is the value? 0.173 square plus 0.9 square. It is 0.916. 0.916 Newton seconds. If you want, you can find the direction also by dividing 0.9 of 0.173 and taking alpha, tan alpha. I think up to 2 decimal points, yes, it is okay. I want to know anyone who cannot understand this. Is there anyone? May I answer that? Right. There are some students who didn't got this answer. Okay. So I need to know everyone understood this properly. So if you understood this properly, please raise your hand. If you can do any question with regarding to impulse, raise your hand. Right. Okay. So there is the last question B, part B. It is asking about the average force. So what is this is the equation we have to use. If they are talking about impulse, we have two equations, F delta T and change in linear momentum. And we have to use those equations considering the directions. That is the main thing. Otherwise, there is no point of these two questions, right? These are very much easy questions. So I equal F delta t. We know impulse is 0.916. 916 equal to average force means F delta t they have given as 4 into 10 to the power minus 1. So if we divide, you will get 0.49. 0.49 newtons. Right. Okay. So now you can do question number 8. No. Here's the question. Question number 13. Quickly you have to do. It is a question related to impulse and do it quickly. It is very easy. Not like this. Those who did question number 13, part 1, please raise your hand if you did part 1 in question number 13. Others? What about others? Only 2 or 3? Yes, they have raised their hands. So, question number 13, part 1. You have to try. This is just even simpler than what we did. So, you have to do it. Questions හදලා හැම එකම හරියන්න ඕනේ නැහැ. ඇත්තටම අර questions මේ තනියම හැදුවම අන්තිමට දේවල් මතක හිටිනවා. දේවල් practice වෙනවා. හදන හැම එකම හරියනවා නම් මේ A level මෙච්චර fail වෙන්නේ නැහැ. ඒක නිසා you have to practice yourself. Before I am doing the question, you have to practice yourself. That is the secret in physics in order to get an A pass. Otherwise, you cannot even think about an A pass. You have to try the question before I'm doing the question. That is the secret. The only thing. To question number 13, part 1, and raise your hands. Right. I will do first two questions and then you can continue. Right. It says hailstones with mass 0.05 each fall vertically into horizontal row with velocity 15 meters per second and rebound at 5 ms minus 1. It is a vertical thing. So we don't want to worry about horizontal impulses, right? There is just vertical impulse, right? The strike rate is 600 stones per minute per unit area. 600 stones per minute per meter square. We can derive the unit, right? Okay, the total roof area is 40 meters square, right? Never mind. The first question. What is the change in momentum of a single hailstone? It is falling at what? 15 ms minus 1 and moving again to upward direction at 5 ms minus 1. So we know the velocities and mass is 0.05. So we know impulse equal mv minus mu divided by, not divided by, mv minus mu, right? So we take m out, v minus u, and now we need to select the direction. I will select downward direction, and then equal to mass is 0.05. 0.05 times what is velocity? V. Final velocity, it is 5 to upward direction. So it is minus 5. Now you know these things. These are easy things, right? Minus u. U is 15 to downward. We did the equation also. We initialize the equation also in the downward sense. So this is a positive velocity minus 15. Right, 0.05 into minus 20. The answer will be 0.5 into 2, 1. Minus 1, is it? Yes, minus 1 Newton seconds. It means the actual impulse of a single particle is I equal 1 Newton seconds. What is the direction? Upward direction. This is the answer, right? Okay. So can you raise hand those who got this question correct? Physical, everyone correct? Yes. So online. How did you got 0.49 for 16B? By using this equation. I equal F delta T. Isn't it the equation for 16B? This is the equation we use, and impulse was 0.9 or something like that. Huh? 0.916 equal force is the thing we need to find, and then delta T. Here, average force means it is also the force, right? Here we are taking the average force. Don't worry and divide by 2, right? Don't worry and divide by 2. Time is 0.10 minus something, 0.2 10 minus 1. So when we divide, if I haven't done a calculation mistake, you will get 2.29. I didn't got 0.49. Is the answer 2.29? 16B. 0.916 divided by 0.4. 91. 2.275, 2 point something. 2.275 newtons is the answer. So what are you talking about? I can't get you. So can you please respond while I'm solving the question, right? Okay. I think you are confused with another question or something. Right. Okay. So the second part, the B part. Okay, so part 2. They're asking what is the total change in total change in momentum in 1 second. Right. What is the total change in momentum per particle? 1 Newton second. It is the impulse, right? Change in linear momentum. And they are asking what is the total change in momentum in 1 second. So we know 600 stones per minute per meter square. So how many stones per 1 second? What to do? Divide by what? 60, right? Because there are 600 stones per 1 minute. In order to take for 1 second, you need to divide this value by how much? 60. You will get how many stones? So we get 10 stones per second per meter square. And also we know there are 40 meter squares. We have to multiply this value by 40 meter square. Then we get 400 stones per second, right? This is a O-level problem, right? 400 stones per second, okay? Now they are asking total change in linear momentum. If one particle, the change in linear momentum of one particle is 1 Newton seconds, so what is the change in linear momentum of 400 particles? 400 Newton seconds. Got it? They're running 400. So it is within 1 second, the total change in linear momentum is what? 400 stones into what? The linear momentum change of one particle is 1 Newton seconds. So 400 Newton seconds. This is the answer. If you got this wrong, don't worry. And you have to correct your mistakes. That's it. You have to try yourself. If you are wrong, correct your mistakes. That is why. That's the thing. You can't get everything correct. That's okay. I also made mistakes. Okay, calculation error. That's fine. So try to do question number 3. Try to do question number 3.
Those who did question number 3, I mean part 3 in question number 13, raise your hand. Pressure මොකද්ද? Pressure equal force over force. Oh, දැන් මේකනේ ඔතන දැන් අපි හිතන්න ගන් එකකින් අපි වෙඩි තියනවා කියලා. ගන් එකකින් අපි උණ්ඩ 600ක් තප්පර මේ මිනිත්තුවට තියෙනවා. හැබැයි ඒකෙන් අයිඩියා එක දෙන්නේ නැහැ නේද? අර ගිහිල්ලා වදින ටයිම් එක. ඒකේ අපිට දෙන්නේ අපි ඕක හෙව්වොත් ඔය යන උණ්ඩ දෙකක් අතර ગેප් එක විතරයිනේ. පැහැදිලිද? ඒ කියන්නේ 600 මොනවාද bullets per minute. ඒ කියද්දි ඒ කියන්නේ ඒක දැන් අපි ඩිවයිඩ් කරලා ගත්තා කියමුකෝ. per second කොච්චර බුලට් ගාණක් යනවද කියලා ගන්න පුළුවන්. ඒ කියන්නේ එකෙන් එනවා මොකද? එක බුලට් දෙකක් අතර තියෙන ગેප් එක. ටයිම් ગેප් එක. හැබැයි එකෙන් කියනවාද එයා ගිහිල්ලා අර බිත්තිය වැදිලා තියෙන ටයිම් එක? නෑ. අපිට ඕන ටොක් ටොක්. දැන් ඔහොම ගහන්න පුළුවන් නේ අපිට. දැන් එහෙම ගහද්දී මම දැන් ටොක් කරලා ඊළඟ එක ටොක් කන්න කලින් අරෝ ගිහිල්ලා වැටිලා ඉවරයි. ඉවරයි තමයි. Yes. We get the time difference like that. Right, I will do third one. Right, someone asked me, can we get, they are telling 600 stones per minute, per meter square. So if we divide this by what? If we divide 60 by 600, what we get? 60 seconds by 600. The time taken to travel, I mean time taken to elapse, ඒක අපි කියන්නේ නිකන් the gap between two bullets, right? Bullets, no, these are particles, right? The time gap between two particles. අපි නිකන් gun එකක් කියලා හිතුවොත්, if we think it is as a gun, I tell you there are 600 bullets per minute, and you bullets per minute, right? Then you divide 60 means 60 seconds by 600 in order to take what? The gap between a single, the gap, time gap between a single, what do you call this? Bullet and another bullet elapsed, right? The time gap between two bullets. This is the thing given by this equation, right? I think you can understand. But does this give the time duration held by the impulse? No, right? It can move like this, and it will be a limited time than this, which will be impactful, right? මෙතන impact එකක් වෙන්නේ මීට වැඩිය අඩු කාලයක් වෙන්න පුළුවන්. අපිට නිසා ඒක conclude කරන්න පුළුවන්ද? බෑ. So can we use F delta T finding a thing like this? No, we cannot use. So we have to go to another way. We have to find another way. So we know 1 second, within 1 second, 400 Newton seconds impulse can happen, right? So what can we do? I equal F delta T. I take this delta T as what? 1 second. So in 1 second, we need the force exerted. I is what? I is what? 400 Newton seconds. Physical students are good. They got the answer. 400 Newton is the force exerted per second, right? No, that is the force exerted, right? That is the force exerted. And finally, pressure. If we know the force, how to calculate pressure? Pressure equal force over area. 400 over area is 40 meters square. It means 10 Pascal. 10 Pascal, right? This is a bit hard question, but if you are wrong with this question, you have to redo the question again and think what happened here. That is the quality you have to practice. Never give up. Never give up on a question. If it is wrong, it is okay. But you have to practice, right? Right. Write down this. If you are wrong, just practice again. Right. We will move to an interesting part. 15 minutes. Hurry. මෙතනින් බස් ඉවරයි. සම්පූර්ණ ඉවරයි. 15 minutes තව දෙන්න. හෙට work energy. Work energy power මෙච්චර අමාරු නැහැ. Newton එක I have to explain more because there are many things which were misconceptions, right? ඔයාලා understand කරලා තිබ්බ විදිහේ සෑහෙන දේවල් වැරදි කියලා අද තේරුණානේ. පට්ට වැරදීනේ ගොඩක් දේවල්. ඉක්විලිබ්‍රියම් එකද? ඉක්විලිබ්‍රියම් එකේ question එකක් අපේ තිබ්බනේ. මම කිව්වා ඒක හිත කියලා දෙන්නම් කියලා. I will teach you that question also with the equilibrium lesson, right? That will be okay. Equilibrium is an easy lesson. I will teach that question with that. And yes, I know. I think many of you got maximum out of today, right? Because this is a lesson done in classes for nearly a year, right? Nearly a year. So we are doing just 3 classes. Yes, it is a challenge, but I think I would not be able to cover hydrostatic part. So I will cover hydrostatic part within an extra class or something like that. Anyway, I will cover, right? We will cover whole mechanics, and yes, it builds our confidence. Right. Okay. So we are moving to an interesting topic. Work energy power is easy. Yes. The problem is you are identifying. Then, I mean, if there is a question, what is the work done? You are finding where is the force, where is the displacement, F into D. Is this the thing you are doing? Yes. Work done is not a thing like that. I will teach you tomorrow. But work done is always change in energy. Always. I noted that students try to find out what they try to find out what the force and the displacement, and the equation is work done equal F into D. That is correct. That is correct actually, but work done has a meaning beyond that, right? Okay, fine. So මෙහෙම scene එකක් තියෙනවා. So if we consider
a fluid flow, we will learn this in detail with fluid mechanics, but just think the mass flow rate, the fluid, there is a fluid in this tube, right? The amount of mass per unit time, the mass flow rate is given by the equation A rho V. The mass flow rate, mass per unit time is given by the equation A rho V. A means cross-sectional area, right? Rho means density of fluid flowing, and V means velocity, right? Using this equation, you can find what is the mass flow rate of this fluid. I taught this thing in order to go for an important section. That is, consider situation like this. We will not erase this one. Consider a situation like there is a flow of water, right? This eject water to a horizontal wall, right? Or not a horizontal wall, a vertical wall. And what will happen? Sometimes it will bounce back with the same velocity. Let's think it's hitting the horizontal wall with velocity v. If it is a higher velocity, it can bounce back with the same v velocity, right? Can you understand? Yes. And also it can, the velocity can be zero also. Have you noted any situations when you are pushing, I mean, when a water column is pushing a wall and then there is no bounce back. There's a smooth movement when the water particles are going down like this. Have you noted those situations? I am now considering a situation where the water particles bounce back with the initial velocity v to the opposite direction. And yeah, okay. So in order to find the force exerted on the wall, I will first find force exerted on the water. To find force exerted on this water, I have to use what? Newton's law of second law of motion, right? I will apply F equal mv minus mu divided by time, right? So here I can take m over t out. V minus u. This is on water. Try to understand. We have to mark forces. These velocities are on water, right? This velocity is to this direction. It is on water. This velocity is to this direction. It is also on water. It is a velocity of water. So we have to apply F equal ma only to water. And then we need to find force applied on water. And can you understand? There is an equal and opposite force F to the other side of the wall. Action reaction pair. So we will apply to this direction to water, right? On water. So m over t, what can you write as m over t? Mass flow rate A rho v, right? A rho v. And then v minus u. V minus u acceleration? No, you have to consider final velocity. It is to this direction. So it is minus v. Can you understand? Minus u, initial velocity, is to the exact same direction what we are considering. It is just v. So we are getting an equation minus a rho v square as the force exerted on water. This is force on water, right? Minus 2a, right? Right. So we are applying the equation to this direction and we are getting a minus result. So what is the thing? The actual force is in which direction? This direction. So actual force is on to the left side, and it means if there is a force to the left side of the water body, it means there is an equal and opposite force right side on the wall.
Can you understand what I'm saying? Is it okay? Right? So what I said, there is a water body and a pipe. So the pipe pushes some water column to a wall with velocity v and it bounces back with exact velocity v. Right? Understood. So what happens? We apply Newton's law of motion, m over t common, v minus u, and then I apply the equation to the right hand side. But remember, I apply equation on the water. Can you understand? Can I apply equation on the wall first? No, because I know the velocity of water, right? The bounce back velocity and the initial velocity of water. So the initial velocity is to this side. It means no, the final velocity v, it is to this side, to the left side. It means we applied the equation to the right side. That means minus v minus, මෙතන minus එක ලිව්වා. U is always to which direction? To the original direction plus v. So we got F equal minus 2AV 2A rho V square as the equation for force exerted on water. So there is exactly the equal and opposite force exerted on water. Can you understand? Is it okay? Right. It is given in page number 12. Right. Everything is given in page number 12 and first section of page number 13. I taught you everything in the section. Right. Let's do a final question. Right. Okay. So question number 8. Here it is about not a liquid. Here it is about a air column. Air is also a type of fluid. You can apply this equation. It is about a situation where helicopter is going upwards. How it obtains its upthrust.
If you have any questions, clarify. The force acting on air particles, you have to consider air particles to apply that law. And then what you need to do? The equal and opposite reaction force acts on the blades of the helicopter, right? Is it? Yes. You have to consider the flow of air particles as a fluid flow, right? So then there is a force created, isn't it? The linear momentum, due to the change of linear momentum, there is a force created. So that force acts oppositely to the upward direction on blades. Then the helicopter moves up. What? P means? Yes. No. Velocity. The velocity at which it is moving. The helicopter is hovering means it's not going upward. It is just in the single point, right? Then what is the meaning of that? Yes, acceleration is zero. It is hovering. Yes. Right. Hands up those who solve the question. Anyone who solved the question, just raise your hand. Right. I will do the question. I think anyone haven't done the question. Am I correct? Right, we'll do. We're out of time. So, right, question number Question number 8. A helicopter is hovering at a fixed point in air. Its rotors push air downwards at a constant velocity 25. If I think this is the area of these blades, right? These are the blades of the helicopter, and this is the area covered by that. And it hovers with 25 ms minus 1 by pushing the air particles at 25 ms minus 1 velocity. Area set by the rotors in rotors is circular with a radius of 4. This radius it is given as 4 meters. And then density of air, rho air equal 1.25. Right. Determine the following. Identify and label all the forces acting on the helicopter while it is hovering. What are the forces? I'll draw the helicopter like this. Right. What are the forces? It has the weight, right? It has the weight and also it has the force on the rotors. Why? Why there's a force on the rotors? They are pushing air particles downwards. So there is a change of linear momentum of air particles in the downward direction. So they are applying a force in the downward sense to the air particles. That means the rotor receives the force to the upward direction. Got it? Right. So now they're asking mass of the helicopter. Mass means if it is hovering, the force is equal to weight. Am I correct? If it is hovering, force is equal to weight. So I will find the force and just divide by 10. We will get what? The mass of the helicopter. Fine. So how do we find that? F equal mv minus mu divided by time, right? So we know what m over t, we can take it out, v minus u. M over t, we can write it as what? A rho v, the mass flow rate. A rho v, and initially what is the velocity of an air particle? Zero. It is a zero. Initial velocity is zero, final velocity downward 25. So I apply in the downward sense. So final velocity is 25 minus 0, right? So area is pi r square, 4 pi r square, 3.14 into 4 square into rho 1.25, and the velocity, what is velocity? It's also 25. It is also 25 into 25 means 25 square. So you will get the answer 3.14 into 4 square into 1.25 into 25 square, 39,250 newtons. But so what is the mass? 3,925 kilogram is the mass of the helicopter. Everyone understood? Right? Right. Physical students done a great job in the final question. Right. What about online students? Do you understood? Can you understand what I said? Right. Okay. So sorry, the chat. Understood. Right. Han, go then. Then අද අපි සෑහෙන වැඩක් කරා. හරිද? නිව්ටන්ස් වල ඇත්තටම මෙතනින් එහාට එන්න දෙයක් නැහැ. There's nothing beyond this, right? We discussed all the question patterns and all the applications of Newton, unless there is one thing, there's a 10-minute section. What? Advantages of friction. Yes, right. I will teach that tomorrow morning, 10 minutes, just 10 minutes, and we will try to complete all energy concepts, and moment is a small section. We don't need to worry about that even. I will do that in a simple, a small amount of time. And then the thing is equilibrium and center of gravity. So we will try to do those things tomorrow, and then the day after tomorrow we will be completing circular, angular, and rotational motion, right? අපිත් එක්ක දැන් පටන් ගත්ත වෙලේ ඉඳලා ඉවර වෙනකම්ම කට්ටියම ඉන්නවා, right? එතකොට ඇත්තටම ඔහොම ඉන්න ඩිසිප්ලින් එකක් තියෙන්න ඕනනේ. එතකොට සයන්ස් කරන ළමයට ඇත්තට මේ ඩිසිප්ලින් එක ඕන. ඒ ඩිසිප්ලින් එක නැතුව without that discipline you can't do these subjects. So you have to select any other subject. So you need that discipline, you need that consistency. If you didn't understand anything I teach you today, so you can ask me. You can ask me while WhatsApp message or something like that. So now you can refresh. You are working from the morning. Now you can refresh. Just take a small nap even. That's okay. And then you can practice questions from Newton under Pesuru, right? There is a Pesuru book. There is the Pesuru book. So you did many things today.
So now you can practice questions today, right? Hi. Then tomorrow, some students will not attend because of the Urdu scene. Right. It doesn't matter because we can celebrate Urdu in any time, right? Lifetime. ජීවත් වෙන කාලේ හැමදාම අවුරුදු ඉතින් සමරන්න පුළුවන්. හැබැයි ඉතින් මේ 27 ළමයින්ට පල්ලි 27 ළමයින්ට මේ අවුරුද්ද වැඩේ කරගත්තේ නැත්නම් ඊළඟ අවුරුද්දේ අවුරුදු සමරන්න වෙන්න රතිඤ්ඤා ගිලින්න තමයි වෙන්නේ. මේ 26 කට්ටියටත් ඉතින් මේක last chance. හරිද? So don't worry about anything. We will cover as much as we can because this is a vast syllabus. Mechanics is a vast syllabus, vast area in the syllabus. So we'll try our best. And also, if we couldn't cover the whole mechanics, I will upload you. I will do anyhow. Anyhow, I will complete mechanics as I said earlier. So yes, it is the situation. So, and also I need the suggestion from you through a WhatsApp message. Don't try to WhatsApp to the admin. He is not me, the one who is messaging. Send a message to me. There's the group admin. There are two group admins. One is named as admin and I'm named as in my name. So you can send me a WhatsApp message. Any recommendations, or did you understood everything? Have you understood? Did you understand everything today I taught you? And yes, so we can conclude the session. Thank you for being throughout the section. I think you understood many things and you learned many new things and you practiced many questions. And now you can do questions with your own, right? So try to do questions with your own after a small relaxation and try to figure out things, right? Okay, so now we can leave. Hope to see you tomorrow, right? Okay, then goodbye, good night. Welcome.